In today's episode, we'll be coding a Wordle game. You guess a 5-letter English word and you try to get to the correct word by getting different colors to guide you to the correct answer. Let's get started. Okay, sup guys? Welcome to today's show. So today we're gonna create a Wordle game. And in order to create a game like that, we need to have a lot of words of 5 characters. So let's begin by going to Google and let's search for English words txt, and we scroll down to the this one, University of Michigan, and then we download this link right here. Copy link, and let's go in here and let's set the home directory to current working directory, and let's wget this file. So if we open this up in VI, we see that we have all these annoying Windows new lines. So let's use col to remove that. And then we have word list dot. Let's also sort and unique them. And then we have a word list dot txt, and we check the head. Seems okay. We check the ending, right, and we open up in VI, and let's remove this empty line here. And what else do we do? Okay guys, so now we have our wl.txt, and if we check how big it is, it's 69,000 lines. The next step is to only use the 5-letter words, right? So in order to do that, we need to do a little bit of regex magic, regular expressions. And since this is a beginner video, I will try to make the easiest regex possible. Alright, so we use the grep command and we add dash big E to use the extended regular expressions. And what do we put here? Well, first we begin the line. So think of the file. We begin the line inside of the file, and that was this caret thing means. And then we can have a dot. A dot means any character, and we want 5 characters, right? So the naive way would be to do just dot, 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 5 dots. And then we need the end of the line. So this ought to collect only the 5-letter words from this word list. Let's see if it does that. So WL 5-letter words .txt, and we do a head of that new file. That seems okay. And we do a tail. And my understanding is that if the head and the tail looks right, then it has probably worked. But we can use the more command as well to be more certain. So you press space to go down one line. And a lot of these seems almost like random characters, but every single one of them is a legit English word. What did we have there? I saw a hole somewhere. This. CME. Why did we get that one? That's very odd. You know what we can do? It seems like only some of these words, like a very small amount, is not 5 letters. So let's, instead of digging into more regex magic, let's just add a function in our code that checks that the word is 5 characters. Otherwise, it will just skip that word. We can also do something like sort dash big R in this file. And we put it into wordlist.txt. We clean up the ones we won't use. So that's WTL, TXT, and the W file. So find one last check. We do the head of the word list. Sounds okay. Besides that head, perhaps we did match on words that are already less than 5. That's probably it. Never mind. So yeah, I might have a solution, but in my head, but I don't want to dig into that right now, because that can be pretty time-consuming and advanced. So let's see. We will also check how many words we have. Alright, 5,000. That's probably so every user of this game will never see a duplicate, right? Okay, so let's see. Let's begin coding then. I have already prepared my VS Code directory right here, and I'll create a new file which is called Wordle.c. And I will not use an H file this time. I will only use one single file. And this is the Wordle.c. And let's see. I think I can minus once. And I need to resize this window a little bit. Yeah, good enough. Okay, I hope you see this. So we have the Wordle.txt. And let's include all the things I usually include. So we have standard IO, we have UniSTD, we also include stdlib, And finally we include string. And that's it for now anyway. Alright, so what do we need? Well, we need a function which is able to check if the character in question, so it checks one character. Let's say the word is apple, and the user provides the letter A. Then we want to highlight that this A is in the correct place. And maybe next time he supplies, he does supply another word. So what should we take? Canon. So C is not there. The A is there, but it's at the wrong place. So this will be yellow, right? And yeah. And then he might do something like I'm trying to figure out a 5-letter word beginning in A. What about atoms? Then the A will be at the correct place. We have no T, we have no O, no M, no S. So that's how it's supposed to work. We will have one function which checks one character, and then we loop that for all the 5 and presents a result. But first, let's define a simple structure. So let's call this word, S-word. S is for struct, by the way. And a struct is a blueprint for an object or your own defined data structure. So you take several variables and you push them into one unit. And why do we need this? Well, first of all, we will need a string. So let's call this the actual word. And this doesn't have to be bigger. Let's do 8. It will be 8 anyway, because they can't be any smaller, right? Alright, so we have the word. What else is interesting about this word? Do we need some more instructions? So each word will be saved in memory, and we will also let's have a size. I will try to do as simple variables as I can, so no unsigned int 16 bits, etc. So let's have a size, but it will always be 5, right? I don't think we need this struct at this time. We might need one for the guess later on, but not currently. So instead, let's just create the main, by the way, so we will be able to compile this at some point, like so. And let's be vigilant with the function definitions, because that is a good practice. So as soon as you define a function, make sure to create the function definition as well. And basically it's the first line of the function, but with a semicolon at the end instead of this bracket. And you put them all at the beginning of your code. Alright, let's just compile it. So we do GCC, and we don't need any we can have wall, by the way. W all means that we get all the extra warnings and stuff. That can be good. And we have the Wordle.c, and we want the output to be Wordle. Okay, no problem there. Okay, so let's create this function that checks one single character. So we can begin by doing the signature of the function. So, and what should it return? It should return, that's what I was thinking about earlier. I will show you. I want this to return a result, right? And I'm going to show you what a result is, or what it will be. And let's call this function check char, perhaps, or maybe just cc check char. And what does this function need? It needs two characters, right? It needs the actual correct words character, the one we are comparing. So let's call this correct. And then we have the guess character. And that's basically it, I think. Perhaps we do need the, let's see, we need the index as well. So let's do int idx, that's short for index. And then we will need the actual word as well. So the word will be, let's see, the word will be a char pointer. I will try to avoid pointers, but in this case it's a string, so that's always denoted as a pointer when you call a function with it. Okay, so this is the word in question. We need that in order to figure out if the character is in the correct position. And let's do let's move this up to here. Make a little space, and let's see. Okay, let's create the function definition right away as well. So we have cc, and we send a char, and we don't give the name of the variable here, we just give the type. And we have another char, and then we have an int, and finally we have a char star, right? And we also need to define this result, and for that I think we do need the struct. So sResult, and what do we want to return here? So let's see. We want to say one of three things, either if it's green, yellow, or red. So let's just call that color. And let's define the colors as standard definitions. So result green. Let's do that 0, and let's define result yellow as 1. Let's start by 1, by the way. Then we can have this as 2. And then we have red, and let's do 4 for that. And why 4 instead of 3? That has to do with flags and stuff, and I don't want to get into that in a beginner video. I have good other videos about that exactly. Okay, so we send back the color, and do we need to tell the main program something else? Yes, we need to tell the main program what index the different results are connected to. Maybe we should return 5 results. Or at least 5 colors. Like so. And yeah, let's do it like this. And then we use typedef just to make it give it a suitable name. So what we want to change is the struct as result, and we want to call it result with a big R. And that is what we are returning here. Okay, I think this will work. So at this point, we're only going to return 1 result. Are we overcomplicating this? Let's just do this instead. type of struct, instead of doing this as a struct, I still want the result, but let's just make this a char, because then we can use these definitions against this char instead. So that means that in this case we return one result, but in another case perhaps we will return several results. So we can even annotate that by doing typedef result 5, because we only ever gonna need either one result or 5 results. So let's call this results with an S at the end. I think you can do this. Okay, enough of that. Let's begin creating our function. So basically we will have a single switch statement here, and what we want to check is the word, but we want to check the IDX position. So if that is 0, we will check the first character in the word. And what different possibilities can we have? We can have the same, so we can have a case for correct. I don't think we need to have this guess parameter, by the way. So this is quite usual when you code. You optimize it step by step when you figure some other better solution out. So let's remove one of the chars here as well. So okay, so if we pick the correct one, and then we will return. I wonder if you in the last C version just can do something like right, it's not a struct, never mind. So we will simply return one of our constant definitions, and that'll be result green, because if we pick the correct letter at the correct place, then we can just return that. What else do we have? We have a, let's see, we can have a default where we check with an if statement if the let's create a function called isIn, and we do correct. So if the correct if the guess Yeah, okay. Instead of correct, I think it will be better to have the guess back. So let's define our correct. What just happened? Let's define our correct right here instead as a regular local variable. So the correct character for that position will be the word at that index, right? Okay. So if the let's see, if the correct character is inside of the word, but since we are at the default branch, it will not be at the correct place. But if it's inside the word, then we can also early terminate. We can return result yellow for that position. And in all other cases, we can denote that by just going outside of this. Since we return in both possible cases, we can just return the other thing right here. So that will be a return, and let's see, red, like so. And okay, then we have a CC function, you guys. Did you learn anything useful today? And do you want to support this channel? Go to drbirch.com/support. You can also click the button Become a Member. Thank you for your support. Okay, welcome back everyone. Let's continue with our Wordle game. So this far we have written a function which will take one single character from the guess and compare it to the different possible results. So it can be either green, yellow, or red. Now we want to write a function which takes the entire words and calls this function 5 times. So let's begin by defining the signature. This one will return results. So that is 5 units of the result type. And the last function was called cc for check char. Let's do this cw for check word. And what do we need here? We need, let's see, let me just check something. Correct equals word at index switch. I think we might have made a mistake here. What we want to compare is the guess. So the guess should be checked against it if it's correct. Let's see if the word is the correct, and in here we ought to do the same, right? So we should check the guess against the word. Alright, that's better. Alright, so let's see what we need here. We need the entire guess word, and we need the entire correct word. So let's name it the same, but this time we'll put a star in front of them. So we take the guess, and we take the word. Like so. Let's give us a little bit of space to work. And we need some kind of result variable. So let's do results res. And we need an integer as an index to go through all of these characters. And let's see, that should probably be enough. Let's try it. Alright, so we start index from 0. At each iteration, we want to check if I is less than 5, and then we increase I. And what do we want to do at each iteration? Well, we want to set the res I, so the current character that we are investigating, and we set it equal to our cc function. And what did it take? Okay, now we made the whole thing up here. Let's move it later. Okay, so we have a guess index word, and that is the correct word. So the guess will be guess I, because it's a character that we are investigating from the guess. And then we have the index, which is simply I. And we have the word as the correct word, right? Yeah. So when we create those kind of helper functions like cc, it makes it very easy to write functions like this. So let's simply return res, and we're done. And let's see, let's move this whole thing. Let's put it here. And then we create the signature. That was our intention from the beginning as well. So results and C word, we called it. And it only takes 2 char pointers, or 2 strings rather, like so. And now we have coded a couple of functions, so I think it's time to test our code. a little bit. And in order to test the code, I want to create one more helper function. Let's call this, let's call this print, or let's add the prefix example so we can easily find it when we want to remove it, because this should not be in the finished product. This is only for us now. Okay, so the example, what does it do? It takes a let's see, we need a name for it first. So example print results, and it takes a results variable like so. And let's move this up here, but let's also put it here, and then we give this a name, res, and what do? Well, we have the results. We just need to go through the results and print it somehow, and we are going to print it more good looking later on, but at the moment let's just do some kind of naive implementation of this. So let's loop through the results. We set I equal to 0, I less than 5, I plus plus, and at each iteration, what do? Well, we do a switch of the results at that position. Right. And there are 3 different possibilities. So, case, we can have a result green. And in that case, we, let's see, we just print something like green. Let's make it easy. And we break. You always need to end a case statement with break or return, unless you want it to continue. And then we have the result yellow. Let's copy this line, paste it here, and type in yellow. And finally, well, let's break first. Finally, we have case result red. We'll do the same here. Break. And then we probably don't need a default statement, but you never know. Something can go horribly wrong sometimes. So in that case, we can print unknown, and then we print the integer value of res I. and at the statement at the end, you don't need break, but I usually put it there anyway, just out of habit, so I don't forget it some other time. Alright, and this is all this function needs to do. And we don't need this return statement, it's a void function, but I usually put it there as well. I like to have structure. Alright, so let's try this out. So let's see. Let's begin, by the way, by altering the signature of main a little bit, like this. And in here we put the argc and the char argv. We check if argc is less than 3. That means we did not supply 2 arguments. And then we print the standard error. That's just the default thing that you ought to do when you work with a command line arguments. So you print the usage, how it's supposed to be used. And it's usually done like this. Let's do this. Correct word, guess word. And then we give argv 0, which is our binary executable file, and then we return -1. So if we don't have the correct argument, this is printed and we quit. If we do have the correct argument, let's create 2 pointers, and I'm trying to avoid pointers, but in this case it's a very easy kind of pointers, and it will improve the readability of the code. So let's create one for the correct, let's just call it correct. It is the correct word. And then one for the guess. Set the correct equal to the first command line argument. We set the guess equal to the second. And we also need one results variable. Then we set result equal to our check word function, and it takes the correct word and it takes the guess word and returns results. And then we can give this result to our example print results res. So this should work, I think. There's probably some small bugs here and there, but the compiler will help us find those. Alright, so let's see what it says. We run the same GCC command as before, and we get a couple of errors. Let's see. Okay, it doesn't seem that typedef has a support for that kind of structures after all. Typedef result 5 results. What if we were to do typedef struct s result? I think we named it something like that. Or do we have it? Right, it's not a struct. It's a char. So this should be a char 5. That ought to be possible, right? Let's see. And we space down a little bit and do clear. And that's so it's easily found first or the last invocation of the command. And we go up and no. Expected identifier or parentheses before that token. Before that token. Never mind. Let's not go too deep into this. Let's remove this and just replace it with results like this. That should work, right? I think we can do it in the whole file. I'm not sure if you have the Vim motions installed, but in case you do, if you zoom in a little bit here, you can issue the command %s and then a comma, and we will change results to result like this. And we want to do it globally, but we want to confirm each and every one of them. Right? Example print result, yes. Results, CV, there and there and there. Alright, let's see what it says. Probably we need to, in some of these cases, by the way, let's go back here and we do result, one of these. Result bracket. So void example, this is right, I think, because it's a signature of a function. In this case, it should be the same. And there as well. But when we define variables, we probably need to put the 5 there. And same here. And that's it. Alright, let's see what the compiler says. Okay, expected identifier. It gives the same error, but result. Okay, let's do it the good old-fashioned way with pointers. It's very tough to totally don't use pointers. So let's do this a result star instead. So we search for result in a bracket. Same here, it's a result star. Result star. Here as well. And here, yeah, here as well. No, wait. Since we're defining a local variable result, right, in this case we need to do this. So that's my mistake. Like so. And I think we got them all, right? Like those Tamagotchi thingies. Okay. Case correct. Case label does not reduce to an integer constant. Interesting. Case correct. And what is correct actually? What line was that? 45. Correct is a char. Case correct. So it's not able to. Okay. Yeah, it's in the runtime. Yeah, let's totally scratch this case statement. And let's do, this will be an else if, and let's do an if statement instead. So if the guess, let's see, if the guess, and that is a char, is equal to the word at, or the correct character of the word. In that case, we return result green. If not, if this is in this one, then we return yellow, otherwise we return red. And we never created this is in function, by the way. So let's do that too. And this should be a boolean, either true or false. If this guess character is somewhere in this word, it should return true. So let's make this a bool is in, and what order did we put the arguments? The character is first and then the word. Perhaps we should also give it a no, let's do another way. Alright, so we have a char C and we have a string str. And let's create a result. Let's make it a bool. Let's call it ret for the return value, and it's false from the start. And we also need an int I, and an int size. We set the size equal to the string length of str, and that should always be 5, right? But we might reuse this function somewhere else. So let's do it in this kind of way. Then we loop I equal to 0, and we loop as long as I is less than size, I plus plus, and at each iteration we only do one if statement. If the the str at this position is equal to the C. If so, we do two things. We set the ret equal to true, and we break. That's all, because it's false from the beginning, so we don't have to worry about that. And then we simply just return the ret. Right, I think this should work. And let's do a signature for this as well. We have we have bool is in, and we have a character, and we have string, like so. And also we need to include the booleans, and that's std bool.h, like so. Alright, let's see what it says. Okay, we're getting closer. Return res. Warning, function returns address of local variable. Okay, 77. Let's see what it's about. So we return the res here. And the res is an array, right? I think it ought to be enough to make this static, so we save it in a place where the other functions will be able to reach it. Okay, that's one. What is this other one? Return -1, that is just a typo. 87. Missed a semicolon. And what else? Res equals to assignment to expression with array type. Right. So all this stuff is because we changed the variable type from, to pointers and stuff. 93. So we need to clean up a lot of different things. Okay, so res equal to blah blah blah. I think it should be enough just to make this a pointer to res. So we clear and we run GCC and it compiles without trouble. Alright, let's see if it works now. So let's see. Okay, we forgot a new line. And then it won't fit. Let's do this. Alright. So when we run this, and this is just the example because we will create a game out of this. But we supply it with the correct word and the player's guessed word. So let's see. We give it a 5-letter word. And what did we have before? Let's see. Let's do canon. And we need a guess word with some of these characters inside, at least, I think. So let's do nylon, the fabric. Okay, so the N turned red, or how should we read this? Let's see. It's a little bit weird because the N, okay, maybe from the reverse order, because the N turns green because it's, no, it's not at the correct place. What about the Y? Maybe we gave it the wrong order, because the Y, red, L, we do get different colors, but I'm not sure what it's based upon. I think we need to look over the code once more. And let's see, if we begin with this smaller function, CW. So we define a result and we set the first of this result equal to whatever CC does, and we send the first letter of the guess. Seems right. We send the index I, that should be 0, and we send the word, and what did we give it? The word, guess word. Word guess. Okay, we mixed those up. I hope that's the only error, because the first thing should be the guess. Let's see. By the way, let's undo this stuff. So we send the correct word then we send the guess, and this takes the guess and then the correct word. Okay, so let's change it here instead. Okay, let's try it again. I think there's something else that's wrong, by the way, but let's take that when it happens. So let's do this again. Canon and nylon. Okay, so the N, we got yellow because the end exists here, but not at the correct place. The Y is red because it's not here at all. The L is also red, not here. The O is green because we have O, and the N is green because we have N. It works. The most difficult part of the game is done. Now we only need to do the infrastructure around. So basically we need to read all these words from our list or text file, and we need to randomize the order somehow, and well, then we just need to present it to the player, and in a nice kind of way show the results, not like this, but with actual colors. And I want to do something like, if in this case if we base it on this guess, the N should be yellow and the Y should be red, L should be red, and ON should be green. And at the next line we should do something like this. So yellow, red, red, these are still unknown, and then we have ON already done, and then the user can guess again based on that. Okay. So that is the next thing we're gonna do. Okay, welcome back. Let's finish this game, shall we? The only thing that's left is reading from the file, getting all of these words, and randomize a word each time we pick, and then write the input-output kind of stuff. So reading from standard input the answer and printing the result. Okay, so where should we begin? Let's start by reading the entire contents of the file into a two-dimensional array. I think it will be the easiest way of accomplishing what we want, because we have, let's see, word list. We have 5,195 different words. So let's see. Which is the best way. Yeah, well. Let's write the function. Let's call it, we don't know what it's going to return yet, so let's just do int for the time being. And we will call this read file, and we will supply it with a file. And also a number of items. So let's call this max. And let's make some room. We are going to need a buffer, and it doesn't have to be that big since all the words are very small. Let's make 8 characters. And let's see. We also need some kind of I as a counter. And we need a file descriptor, and let's make it easy for ourselves by using the fopen kind of syntax. So let's open the file first, and let's see later what we need to add. So we fopen the file name with read permission, and put the fd like this, and if not fd, then something is terribly wrong. So let's do something like p error fopen, and let's return for the moment -1. Alright, so that's this. I'm still considering what kind of data structure we're gonna use. Since we know all of the words is going to be 5 characters, I think the most optimized way would be to use dynamic memory. It's something that I actually wanted not to do because it might seem a little bit advanced. But if you don't really understand this part, I have a very good video on dynamic memory and malloc that you should check out. So let's see what we need. We need a char, and it'll be a double star because it will contain different strings. So it's an array of strings. And let's call this ret because this is what we want to return, right? Yes. So char double star this, and then we can really return -1 like that. Instead it'll be char double star 0. Yeah. Okay, if we are able to open the file, then we want to allocate the memory. So let's calculate the size first. Let's see. I wonder if it's possible to define it like this. We can try that. So ret should, no, we need to calculate the size first. So let's create a variable for that. It can be a regular int size, and the size is going to be the maximum number, and we need 5 bytes per variable. Yeah. So then we can malloc. We set ret equal to the char double star version of malloc. We allocate the size. If ret doesn't return something good, we fclose our fd, and we p-error. P-error is print error, by the way, so it prints the thing we specify right here together with the actual error messages from the last run function. And then we returned char double star 0. Alright, so at this point we do have our data structure. We need one more variable, I think. Now we can reuse the size variable. This is mutable C. Anyway. Alright, so we will read from the file into our buff, and the maximum size we're going to read is 7 bytes. I usually take this value -1. And where we're going to read it from? We're going to read it from fd. And then we're going to loop as long as this is true. So it's as long as it is able to read anything. I also want to zero out the buff. So we put zeros, 8 of them. So it's empty and nice before we read into it. Okay, so now we can set size equal to the string length of the buffer, so the word that we have read. And let's see if we read the word canon. Or let's do nylon. We are also reading the new line and we have this invisible 0 after. So we want to remove this new line. Size should in this case be equal to 6. So 1, 2, 3, 4, 5, 6 for this new line. And the indices will be 0, 1, 2, 3, 4, 5. So the 5th index, that is the new line, and that is what we want to get at, because we want to remove it. So string length returned 6, and we want to get at 5, so we take 6 minus 1. We can actually just make size 5 bytes instead. And then we take buff and we index into this 5 and we set it to 0. And at this point, let's see, before we do that, in case string length would return 0, then we're in trouble, because then we'll try to index into -1 and set it to 0. So we need to check for that. So if size is less than 1, then we just continue. But by the way, before we continue, we need to clean out the buffer as well. Like that. Alright, so now we are protected. And now we have basically we take this new line and we create another of these 0 bytes. And this doesn't really count. So next check we want to do is if the size at this point, because it should be 5 if we have a 5-letter word, if size is not 5, then we will do the same as above. We will just skip this one. So we 0 out our buffer and we continue to the next iteration. But at this point everything is alright. We have the correct 5-letter word. Now we just need to copy it to our structure. And we could just let's see. We could just use string copy, but since we are only calculating 5 bytes for each of them in order to save some memory, we could do 6 and then we could just string copy the contents. But at this point it will be easier, although I think the easiest way is just to do this manually. There's only 5 anyway. So we have the return value at our current index. Let's set I to 0, by the way. We call it I, right? Yes. So this is the number of the word we're at, and this this word has 5 characters. So 5p, and it has number 0, 1, 2, 3, and 4. And we should just be able to set it to the corresponding buff. This is not the most beautiful code, but I think it's the right thing to do in this case. We could make a loop or something, but I don't mind. All right. Is there something weird going on with the indentations, by the way? They're inside this loop. No, it's just big. Everything is just big. What to do at the end? We want to memset our buff at 0.8. We want to increase our n. We do also want to check that that thing we ought to do in the beginning instead. So at the beginning of this, no, and is good. After we have increased this, we check that n is less than max. Let's do like this. Let's check that max is less than n. So max should be more than n. Max should be more than n. But if it's not, if max is less than or equal to n, we break. Alright? And when we are done with all of this, we can simply fclose, fd. Think it would be interesting to return how many actual words we managed to get, because some of them is not the correct size, right? So I think it needs to know that. Let's create a structure for that. Let's call it, so what is it we are returning? We are returning words. Yeah, let's call it words. And what are we gonna return right here? We're gonna have a char double star pointer, which points at the array. Let's call it array, or just R. And we're gonna have a return value of type int n. No, incorrect. No, n is good. Alright, and we type def this struct as words into words, like so. So what is this gonna return? It's gonna return words. And oh no, I'm at the wrong place. Wrong function even. Where did we put this? Right here, okay. So instead of char double star, we're gonna do words, read file, and ret, let's keep it like this, and let's create a words, and what shall we call this? Words. So, well, that complicates our error cases. That's a little bit annoying. Well, let's do like if the pointer inside of the structure is 0, then we are returning an error. That's a good enough solution, I think. So in this case, what do? We set words equal to, and can we initialize it like this? So we set the what did we call it? R equal to char double star 0, and we'll also set the n equal to 0. I think this is how it's done in the newer versions of C. And then we can just return this structure as a value. Something like that. And we need to do basically the same right here. So let's copy this. Should be afterwards. And let's do like this. Move this return. Let's jump this in a little bit. So we have close, we print error, words, blah blah blah, return words. And let's copy this again. Continue. No. Oh, I lost my copy. Never mind, let's write this from scratch. It's a little bit different anyway. So we fclose, we set words equal to a structure where we have a pointer called r, which should be equal to our ret, and our n should be equal to I, right? Yeah. And then we return words. And I have no idea if this actually gonna work. I haven't used this kind of solution before, but it'll be interesting to see. So let's run GCC, and we get a few errors. Expected expression before. It doesn't like our initialization. Perhaps that's because we used the wrong version. If we add standard equals C2X. No, still nothing. Probably we need to do that on the same line as we define the variable. I am not very fond of doing that. I think it goes against the C language somehow. But in need we do. So words equals, and words equals, and words equals. Okay, a lot of the errors and warnings disappeared, but not all. Let's see, red equals char, malloc size, assignment to expression with array type. Okay, it doesn't really like that thing. I was kind of hoping that it would understand what I meant when I did this. No, when I did this. Okay. What if? Because the problem is, I think we could probably have done something like this, but that's not really helping because we need the 5 on the other side, and I doubt that this will work. Well, we could try. No, of course not. Alright, we need to do it the good old-fashioned way now. So, char double star ret, and we'll let's see, will this stuff still work? That is the question. it has no real idea how big this should be. What if we were to... Well, we know how big the file is, right? We could make this some kind of dynamic array. That is also a new feature that I haven't really experimented a lot with. But we could just define it as, if we know the max, maybe we can even do it like this. Max 5. And we don't make it a pointer. And we make it static so we can return it. Well, it could work. And since this down here is a pointer, you should also be able to do this, right? Let's see. We probably need to change some other stuff, but let's see what it says. And perhaps we need to specify a standard. So C2x, no, C2x. Storage size of ret isn't constant. No, it isn't, but does it really need to be? With all those what is it called? Varying length arrays and stuff. Well, let's make it easier for ourselves. Let's remove this and let's keep this as is, but let's go to the beginning of the file and let's define max as a constant of 91 of 5. That's the correct one, right? Let's see. Word list there. 5195. 5195. I don't see why this shouldn't work. But we had some other error somewhere. Boof. Right, we should not malloc it. If we're at it's a malloc stuff. We forgot to remove that. Since we are putting this on the BSS segment now, we should not allocate heap memory space. So all of this malloc stuff can be removed. Okay, almost there. N undeclared. N undeclared. Yeah, it should be I, not N. It should be I. And I. N equals I. Alright. And now we have one warning left. Initialization of char double star from incompatible pointer type char star 5. Are they really, though, incompatible? I don't think so. But, okay. Let's see if it's enough with A. R equals char double star. And we need the address of that thing. And we are compiled, ladies and gentlemen. So the next step is testing if this function really works. But this is a good place to stop for today, because we're already 2 hours into this episode. So next week we will finish this game. And if you like what you've seen this far, please like and subscribe. And thanks for watching, and thanks for today. Okay, let's finish this thing, shall we? Before the break, we created a new function which takes the whole file of 5-letter words, and it creates a huge two-dimensional array of it. So let's test this, see if it works. So what did we call the return value? I closed that one down. No, we don't have an H file. Let's see. We called it words, and it contains R and N, right? So what do we have currently? Yeah, we have these tests, and they worked. We don't need those anymore. Let's remove those, and these as well. Alright, so what do we need? We need one of these structures, right? So let's do words, and we let words be equal to, what would you call the function? Let me just see, where is it? Right here. Okay, it's read file and the only argument it takes is the file name. So worlds equals read file, and the name of the file is wordlist.txt. So let's put it right here, and then we should get something back, and inside of this words we need to do a check if words dot r, if that is 0, because then it has failed. So let's do printf failed, and else we want to print something from that array, right? So how do we do that easily? Because it is a pointer. Let's see. Let's go back up here. It is a char double star. And we created it as, let's see, this structure. So it's ret max and 5. So what if we create one of these? So if we do char and we call this, let's see, if we call this something like P for pointer, and we were to do like 5, then we would create 5 different pointers, one for each characters possibly. But I don't think this is the right way. Let's see what happens if we just print from it. The type system must get the information from somewhere. But we can start by printing the other variable, the n. That is a little bit easier, because that's simply words dot n, right? And that is the number of entries in the array, or in the first array. What if we created 2 pointers? But we would still have to know how big it is that we do. So if we were to do something like And if we were to do something like, let's say A and something like A max, would we be able to point this first one to our array, select the word's number, and then point and dereference this one against it? Maybe we don't even need this step. Let's try this. P equals words dot R. Is this enough? Or do we need to do something like, no, we shouldn't have to. And if we then were to select one of these, let's say number 100, can we just print F number 100 percent S and a new line? Can we just do P 100? Maybe we can. Yeah, let's try it. Hopefully we'll get some guidance from the compiler with regards to errors and warnings and stuff, and we'll take it from there. Okay. Assignment to expression with array type. Right. It does not like that apparently. But how do we then tell the type system how to use that one? P equals because it can't just work like this unless it remembers the form, the shape of that array, but I don't think it will. I don't. It did compile though. Let's see what happens. Segmentation fault. Of course. But where does it segmentation fault? Let's see, read, close. It's probably inside of main, one of the last thing we did. Let's do an L trace as well. Quite a lot of these library calls. Let's see, yeah. when trying to print this stuff. Just get a couple of random characters. We need to dereference that pointer, I think. So let's start there. So let's make this a regular pointer. Can we still do this though? Let's see what happens. We are experimenting a little today. So this is what I was thinking. Do we need a parenthesis? Perhaps something like that. What will happen then? We get the warning. Format present as expect. Argument of type char, but argument 2 has type int. That's weird. Well, what happens when we try? Segmentation, of course. Is it at the same stage? Looks like. Let's think a little bit rational about this. What do we have here? We have a pointer to a pointer. Char double star. And we pointed that one against this, the static char ret max 5. Ret max 5. Maybe we should take the easy way out in this case. I don't want to get into GDB debugging and stuff in the beginner video like this. So let's just make it easy for us. Let's see. Instead of returning words, we will return an int, and that is the number of words. Then we take this one and put here, so we make a global variable of this. We need to change it though. Let's call this words instead. Right. So let's see what else we need to change. We need to change this part because we will return -1 with an error. Right. So this stays the same. This too. the result, instead of this stuff, all we need to do is return n. So we skip out all of this stuff with regards to structures and pointers and stuff, and we simply return the number of words, and then we have a global variable holding this data. I don't really like global variables, but sometimes it's the easy way out. They are, after all, allowed in the C language. So then we could just change this to words. Remove this. And this we need to, let's see. Let's remove this, create an int n, remove this, we set this equal to n, if words are null, in here we will check if n is less than 0, then we do this, otherwise we do this, and this will just be n, and the hundreds will be words 100. Okay, I think that should work, unless I did a typo or something. Okay, what now? Ret undeclared. Okay, we did rename it, but we didn't change that everywhere. Right, that's no big deal. Let's see. Let's go to the top. Let's search for ret. Preferably without getting the U afterwards. Like so. Okay, that is not the right one. Let's move on. Okay, here we are. So we want to change ret to, what do we want to change it to? We name this words, and that's it, global, and then we should just be able to do S like this. Great. Let's search for the next ret without trailing U, and we are back about up here. Okay, let's just skim through this function so we haven't forgotten anything. We have buff, isize, fd, we do this, we do that, and at this point we copy. Seems about right. We need to change the signature as well, by the way. So, okay, we haven't even created that one yet. So what do we have? We have int read file, and we have a char star, and that's it. Save. Okay, now it should work better. What is this then? N on it. Yeah, it's not N, it's I. And we have something wrong at 117 as well. Okay, let's go into read file. Read file. Tough to spell read file today, apparently. Here we are. Okay, so where do we have this N? Okay. There. Should be I, and what is line 117? It's this one. Okay. I need to make this a little bit smaller. I will not be able to grasp this stuff otherwise. So let's see, the yellow one is the function. Then we have this, and that is closed. We have a while loop with purple. If statement with blue, done. If statement with blue, done. And this is the purple. And here we close the yellow function. So why did it complain then? Well, let's try again. That's weird. Did I forget to save? Okay, now it compiled. Fingers crossed. Okay, that is actually quite sensible. Because we are not using the null terminated strings, right? So we can't just use stuff like printf, because it will printf the word we're looking for, and then it will print everything after that. But it seems to be working. It sure does. So just to test this out, maybe this is enough. Hope you can read this. To test this out, we may do something like this. So number 100. Let's just print this. And then we print f %c for character. And what character is that? It is the word number 100 and character first. Like so. And we need 4 more of those. So 5p. 1, 2, 3, 4. And then we will just print a new line. And lo and behold, okay, this went a little off, but let's fix that. And there should be a new line here. And let's do 2 right here. Great. There we go. Word number 100, tiles. Okay, so that works now. That is fantastic. All we need to do now is create a function which does a random number between between 0 and the number of words that we have, -1. We had quite a few actually. 5195. Isn't that pretty much all of them? Yeah. Why does it not exclude the 3-letter words? Let's check something out. Word list. What is this? Okay, so is this why it... That's weird. Let's do a search for anything which is not A to Z. We have this. And there we have a dash. That's not good. But let's remove them as we see them. So off you go. This and a parentheses. I can leave it like this because our program will remove the 3-letter words. So here's another, and here too. I wonder how many there are. Maybe we can do this all day. Let's save this far. And let's do a regexit instead. So let's do, we grep. Let's see. We grep all the words which are just A to C, and how do we write this? It should be 5 characters from word list. No, it didn't get all that much. There's always trouble with this repeat thing. What about A to C plus? No. And maybe we need to add the dash E. Okay, then it works. Does our first one do as well? Yeah, perfect. So let's pipe this to a new file. word list 2, word list 2.txt, and let's do handle that file word list word. It's annoying that both the program and the list begins with the same characters. Word list 2, and the tail also looks okay. How many do we have? Word list 2, 51, 72. Okay, so a couple went away at least. And if we were to go into the word list 2 and we search for any character not which is not A to Z, we get nothing. Great. Okay, so this is what we want to use instead. Let's remove the first file. Word list txt and word list, and we remove the 2. Word list. And if we run our program this time, we have 5172. And we get another word, by the way. Great. So now it will be very easy to write a random function for this. All we need to do is, let's see, we want to return a string. And let's call this random word. And what do we want to give as an argument? All we need to give is the number of words. So int max. And we will just do something like this and create a, let's see, let's create an X or something, and we call the rand function that we want it to be no bigger than max, like so. So now we have a random number, and maybe it will be the easiest to, but not. Then let's not settle for easy. Let's do this instead. Let's see. We create a string of 5 characters. So char ret 5. Then we copy manually like before. So ret and the number is equal to words X and the number, like so. We need 5 of these. So let's see, 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. And in order to make things a little bit easier, perhaps we should make this 8 bytes and add a 0 at the end, so we can return a proper string, right? And if we were to make this one a static char, then we probably should be able to just return it as is. So return ret. Okay, so this should pick a word randomly if we give it a max. Let's see, if we remove all of this stuff, or not all of it, but let's remove these printfs. And let's create a pointer p. So let's printf word and the %s. Let's put it inside of these quotes as well. And then we call our function. What do we call it? Random word. And we need to random word. We need to give it the n as the maximum, like so. And then we don't even need this p, because we call it directly. We need to seed the random generator though. So let's create a small seed function which will simply do x equals get pid. We take the pid and we use that to seed our random generator. And I will not go into the details of how that works right now, but if you are interested, please check out my random value video. It's one of the old ones with a ugly penguin. Okay, so we do seed, the first thing we do. Let's also create a couple of signatures. So we have seed, we have void, seed, void, and we have info char random word, and it takes an int, and that's basically it, I think. Now what? 11. Okay, this collides with what we named that argument, right? Let's go to random word, and we change this to something else. n. Where did you use it? Just there. Save. Let's try again. What is this? Words undeclared. Aha. We should move this up a little bit. Because we created this variable right here. This. We created it down here. So instead, let's just put it somewhere at the top. So, like, there. Then we try again. Okay, just one small typo left. 151. 151, and we change this to a semicolon. Save. Oh, now I did save quit. Old habits die hard. Okay, and we go right here. We jump down a little bit. We try again, and this time it worked. And let's run our little game. And if this works, it should print out a random word every time. Servo, dagan, think, chuff. Yes, it works. Very nice. All we have to do now is providing the infrastructure for the actual game loop, which shouldn't be very challenging, I think. Did you learn anything useful today? And do you want to support this channel? Go to drbirch.com/support. You can also click the button Become a Member. Thank you for your support. Okay, so now we have basically all the different building blocks. All we have to do is put them together, add a function or two, and create a game loop. So let's begin with the game loop. Let's do void game loop. And we are also going to create yet another global variable. And I'm going to call this, let's make it a bool. I will call it continuation. So this is gonna use it's gonna be used for the loop, basically. So when we start this program, what we'll do is we will seed the random number generator. We'll read the file. We can change all of this stuff and just put in an assert that n is greater. Let's see. Let's do it like this. That n is not less than 0. Right? Then we will set the continuation to true, which means we will continue looping. So while continuation is true, we will run the game loop, like so. Perhaps we should feed the game loop one specific word. Let's see, how did I do that before? This is all the preparations is in random word. Here it is. And it takes in the max, right? Okay, so let's see. Max is this n. And let's create a char pointer which we'll call p. And we will simply set p equal to random word, and we give it n. So now we have the word, the correct word that we're gonna guess, and we feed the game loop that word. So we add a char correct right here. And let's go to the top and do these function declarations. So void game loop, and we give it a char star, like so. And let's begin by rewriting this example print results, and let's call it print results. And it takes a result star. Is that still what we use? Yeah, I guess it is. So print results. And we get the result from checking the word. Right. Alright, so let's go to the print result. Let's remove this. Let's see. No. Never mind. Alright, so what does this do? Case result green, result yellow, result red, and it just goes through each and every position. So we can use this almost the same, but instead of printing like this, I want to print like this. So we will have an S and then a char, and then another S. The first being color green, the second being, let's see, res I. So we need the character. How did we make this result thing? Type def char result. Let's go into this CW function. So it checks the word. Static result. Okay, so it's an array of 5 characters. And it contains the colors. Because we need access to the words as well. I think we need to change the signature of this function. So print results. Let's take in the result, but also the word, also the correct word and the guess. So char guess and char correct. Because then we can do, let's see, color green. Then we have selected the correct letter. So let's put in our guess at the position I. And then color stop. We're going to define those colors a little bit later. And let's copy this to each instance. And remove this old ones. Right. So result yellow. Then we're gonna have color yellow. And are we gonna print the guess, the character? In that case, yes, we are. Right. And then color stop and color red. It will be basically the same right here. And then we will simply end with a new line. Like so. And let's see. We will also have some kind of prompt that looks a little bit like this. So how shall we do that? We need to save the correct guesses. So we can produce the prompt. And how do we do that in an easy enough kind of way? Well, let's say we have a function called prompt, which will take let's make it an make it an int array. So indexes 5. No, not int. We can make this. Let's see. We can make this bool actually. Let's name this corrects. And it will look very similar to this function. So let's copy all of this and let's put this back. No, that's not right. There it is. And let's also put it in here, down. And we'll change what we need to change. So we iterate through these 5 characters and we switch for each one. We switch for the corrects at that index. And then we will have 2 different cases. We will have case false and we will have case true. And that is if we have guessed that character correctly. So let's just print if we have false, then we just print a line, minus sign, remove this. If we have true, on the other hand, then we will print that character, which means we will need at least the correct word, the correct of I. And we don't need this or the default. And then we print that. So we will have the corrects and we will have the correct word. That will be the prompt. And since it's a prompt, we should end with something like this. Perhaps we should have 2 new lines before it. Like so. And then we need to flush because we're not ending with a new line. Okay, I think this will be good. So void prompt bool It'll be bool star, I guess. Char star. And bool star, correct. The rest will not change. Oh, we need to remove. That. This way we can always know which characters we have done. Let's see. Let's create another global variable because we need to keep track of how many rounds we have played. Rounds. Let's go to the end and we will set rounds to 0. Okay, so what do we do in this game loop then? Well, the first thing that we do is that we will actually do before the game loop, by the way. We will just print out 1, 2, 3, 4, 5 and a new line this, because I don't want to call the prompt before we have something to give it as an argument. std out. We have just started up the game at this point, but we'll still want to print something showing that we have a game. So the first thing we do is check if rounds is 0. If rounds is not 0, then we call the prompt. And what was the arguments? An array of bools and the correct word. So we need to keep track of this as well. Right. Then we should probably, it will be a lot of global variables, but I think it will be okay. Alright, bool corrects 5. And from the prompt we can erase this. We need to initialize the that as well. So correct, let's see, equals false. 5p It's not very beautiful code, by the way, but it'll do the job. And then we can change this. So we don't need to print anything before the main loop. We don't need this if condition. We can just do the prompt directly with the correct word as an argument. Then we will read from the user, and let's real quick just create a read line function. So it's char read line, no argument, and we create a buff of size 8. Mem set that buff with 8 zeros. We read into that buff. And we want to read only, let's see, we probably need 7 here. From the standard input, which means that we will have A, B, C, D, E, and then the new line and the 0. So we need a size. We set the size equal to the string length of buff. And then we check that if size is less than 0, let's do like this. Assert that size is bigger than 0. Alright, then we can do size minus minus. We can take buff size, set it equal to 0, and we can return buff. And we need to make buff a static, and then we have a read line function, which is safe, can't be buffer overflowed. So char read line, and let's see, void, like so. We go to the main loop, we go to the main loop, game loop. Okay, so we prompt, and when we have prompted, we will read a line from the user. So char input and input is equal to read line. So when we have the input, we will need a result. The result is equal to the check word, And what is the arguments for that one? CW. We take in the guess and the word. So the guess is our input and the word is our correct, like so. Okay guys, let's continue with this program. I think we need to add a function, a validation function, because I just came to think about that the user shouldn't be able to input A, B, C, D, E, for example. It must be a valid word or the user will lose one turn. But on the other hand, if the user or the player inputs bad input, like 2 characters when it's supposed to be 5, then I don't think they should be penalized with anything like that. So let's begin by creating a return type for this validation. So let's say we have validation OK, that is 0. Let's say we have validation bad input, that is 1. And finally we have validation no such word. So we use the same database with the 5,000 words that we use to randomly generate the correct answer for the game. We use that same database to validate that it is actually a valid word. I think that'll be good. So let's see. We can create typedef. So typedef char val result, and that'll be one of these 3 then. And then we create our function which will return a val result, and let's call it validator. And all we need is a char star for the actual word that we have put in. Alright, so we will have a val result, and we name the function validator, and then we'll have char word. So first of all, we'll check the length of the word. So n equal to the string length of word. And if n is not equal to 5, then we early return, and we return the, let's see, val, what did we have? Val bad input. If it is 5 characters, then we check it, we loop through our database and we check if the word is in there. So we need, let's see, what do we need? We need some kind of counter. We can use that n again, but we do also need something for the actual loop. So let's do an I. Okay, so how do we structure this? We can't use string compare because it's not null terminated strings. So let's do something of like this. For I equals 0, we're gonna loop as long as I is less than max, and I plus plus. Let me just double check this definition. Max 5195, yeah, that's one. Right, so at each step we need to run our own string compare. So let's do this. We set n equal to 0, and then we count how many discrepancies we find. No, we count how many similarities. How do we do this? Because we need to loop through the entire list. Let me see. Let's write this function call and let's see what it comes up with. Let's call it string compare underscore, since we can't do a prime, and we want to compare the, what did we call it? The database words. So we want to compare words I with the word, and let's say this string compare returns a bool. So if it's true, these two are equal. Yeah, we can do it like that. Let's create a bool which we call ret, and ret is equal to false. False meaning that the word hasn't been found in the database. So if these two are equal, what do we do? This doesn't look quite right. This is better. Okay, so if they are equal, we will set ret equal to true, and we will break. So that way we go through everything, and then if ret is true, everything is okay, we return val okay. Otherwise the word is not found, we return val no such word. Right, so now we only need to create that function. Let's make it a local one on the stack. So we need a, let's see, no, we can probably just do it like this. So bool, what did we call it? String compare, let's say prime, and then we have char str1 and char str2. And in here we can count the similarities. So S for similarities, S equal to 0 from the start. And then we can do a simple for loop where I equal to 0. We're gonna loop as long as I is less than 5 and I plus plus. And if str1 I is equal to str2 I, then we increase the S. And that is probably all. And then at the end here we will return, check that S is equal to 5, because we need all 5 to match. And if that is the case, we return true. Otherwise, we return false. That ought to work, right? I think so, at least. So let's see how we will implement this in the game loop. First we prompt, then we take the input. We will have a val result, val res. So we set the valres equal to validator input. And then we switch the valres. And we have 3 possible things. We have a case val bad input. If this is the case, we will printf bad input, just like that. And then we will simply return by not doing anything else. Then we have the case of val no such, what did we call it? No such word. I need some spaces right here. Can't work at the bottom of the screen. And in this case, we're gonna print no such word, only 5-letter English words. Are permitted. something like that. And now we need to increase the turns. Did we create a variable for that, or how did we do that? I don't remember now. Let's see. These are int rounds. Good. So let's see. Where were we? Game loop. And before I forget, let's go into the prompt and let's indicate somehow what turn we're on. So let's see, how do we print this? Just one of these. Well, let's just put it right here then. So turns. Then we go back to the game loop. And in this case, they have tried to breaking the rules. That's why we increase the turn, so they lose one shot. And then we return. And at the default case, if it's okay, we don't really need to do anything inside of these switch statements. Let's just put break here so it looks a little bit consistent-ish. Then we do the res equal to this, and we did add some global variable array, I think. Yeah, this keeps track of how many correct answers we have, and it must be the check word function which deals with that, right? So check words just checks through the correct ones and sets res I equal to cc and returns the rest. Okay, so we get the result from there. So we need to check through these results and update our res accordingly. Or perhaps we can do that inside of the check char. So what does this do? It's correct equals word idx. If guess equals correct, return result green. And we have the index. So we can just add one line here. Before we return, we set the corrects at index idx equal to true. And let's see, else if, and all are false from the beginning, and they can't go from green to any other color later on. So this is perfect for us. Okay, so we check the word. And then we need to count how many correct we have. So let's see, we need an int I, and something that counts how many are true. So for we set I equal to C equal to 0 from the beginning, and we loop as long as I is less than 5 and I++, and we check if res at position I is equal to, no, this is not it. What we want to check is if corrects at I is equal to true, and then we increase our C. And if C is equal to 5, then we have all the 5 correct letters, and we win the game. So let's say win equal to true. We will create this one, and then we just return. Okay guys, so let's continue. So if we have 5 correct letters, then we set the win to true. We will also set the continuation equal to false, which means we are going to break out of this loop, and then we will return from here. And let's see, we will also check if, or let's decrease, let's increase the rounds, and let's see. So at this case it's 0 from the beginning. When we have played once, it will be 1, 2, 3, 4, 5. So if rounds is more than 4, we set win equal to false, which will indicate that we have lost. We will set continuation false, and we'll return. These are all the cases, I believe. So either we win, we lose, or we keep on playing. So let's define this variable. It will be a bool win. Let's also copy all of these global variables, so we know that we have 0 initialized all of them. So let's put a comment block right here and paste them in. So let's see, corrects we are dealing with here. Rounds I think we have dealt with there. Continuation, I think we set it to true, yes. This we will deal with when we read in the file. So it's only the new win variable we need to take care of. So let's set win equal to false. And when we go to this ending right here, we want to print the correct word. Correct word was and we store that inside of P. And if win is true, congratulations, you won the game. Otherwise, you lost. Game over. Like so. And then we return 0. So what do we have left? It's only the colors, I think. But we can, if we define the colors temporarily, we should be able to fix all the errors. Let's see. So what did we have? We had color green, empty string, color yellow, empty string, color red, empty string, and then we have the color stop as well. That too an empty string. Alright, let's see what we have. Please note that we have created a lot of functions since we last compiled this thing. So we will have a lot of small errors which will be very quick to fix. But there might be a lot of them, so let's see. Here is the first one. Correct is undeclared. Yeah, I probably meant correct. So this is on line 86. Let's see, switch, correct, yeah, it should be correct. So let's compile again. Error turns undeclared, yeah, it should be rounds, not turns. So turns should be rounds, and turns should be rounds, and that's all of them. And then warning implicit declaration of assert, alright, we need to include that stuff. So we need assert insert dot age, we need our number dot age, and we need to define underscore GNU source, like so. Line 242, we need to change to a semicolon. And then there's only one, result res, variable res set but not used. Okay, 249. 249. 249. Okay, so how do we check the results then? Do read line, we do the validator, we check the word, we set res equal to that, but perhaps we don't check the results. Actually we don't, and I don't think we need to either, because we use a different method with the corrects to check which letters we have locked in. And this is only for, right, it's for displaying to the user. We should add our print function. Let's see, what does it take as an argument? A result and 2 strings. First the guess and then the correct word. Alright, 249. So when do we want this to happen? We want it before this if statement and probably in between here somewhere. So let's do print results, we give it the res and the guess and the correct. I'm not sure what we call those variables in this function. Do we even have them? We do have the correct. Well, the input is the guess. So let's use that. Input. And now I believe it should compile. Yes, it does. But does it work? That's another question. In order to test it properly, we need to cheat and display the correct word. Otherwise, it will be difficult to test it. So let's do that. And one more thing. When we display how many rounds are left, I want to show exactly that, how many rounds are left. I do not want to show how many rounds, at what round we are. So this should be, let's see, it should be 5 minus rounds plus 1, right? Alright, let's see what we have. Okay, so correct word empty, and it displays a 6, alright? It shouldn't be plus 1 then. That's easy enough to fix. But it never displayed. Let's play around, see how it looks first. Okay, round 5, correct word fraud. So let's input a too tiny word. Bad input. And we still at round 5. What if we input something which shouldn't really be in the be a word? No such word, only 5-letter English words are permitted, and we are down to round 4. Okay, that looks good. So let's input a 5-letter word. What did we have previously? We had empty. Okay, doesn't print much. Well, it printed empty, and we don't have the color highlight, so we don't really see what's going on. And all we get are these. But was any of the characters exactly right? No, I don't think so. What about if we take another word beginning with FR? So let's do Frank. Okay, this time we got 2 dashes. That's a little weird. What if we give the correct word? Okay. Well, the game seems to be working. We do, however, need to work a little bit on the presentation side of things, right? So, first of all, this shouldn't look like this. If we have 2 correct letters, we should see those 2 correct letters. And that ought to be inside of the prompt, right? And we are sending the correct word to prompt. We are switching the correct, and if it is false, we print a dash. If it is true, we print the character at that position. Oh, correct. This should not be correct. This should be correct word. That makes sense. But when do we update this? Is it before or after? Well, it's a new round now, right? So it should work. Okay, let's try it again. That's a weird word. But let's see if we can figure out a word which ends in TA. let's restart this. A back, okay. Abroad, perhaps. Abroad. No such word. Okay. And bad input. Yeah, we inputted 6 letters. Okay, we need to fix that as well. Okay, so let's see. A board, maybe. How do you spell that? Abort. Okay, so this time we did get those letters locked in. That's good. And that's probably as far as we can get right now. Let's do just this, this, this. Okay, so we're at round 0. Alright, so let's see. First we need to fix that 6-letter thing, because it showed both messages. How is that possible? Let's go to the game loop. So we switch for, if it's bad input, we return. And then no such word. There's probably some odd thing going on with the buffering and stuff. Perhaps we can let it be. Actually, we get 2 error messages and both are kind of, if not spot on, they're at least in the neighborhood of right. So let's not worry about that. Let's instead fix the last thing we have to fix, and that is the colors. So we are going to use ANSI colors, which are basically different key codes that affect your terminal. And I don't know these by heart, so we will have to turn to Google. So let's see, ANSI colors C. No, this is not it. Adding color to your output from C. The urban penguin. Here we go. So it's a slash and 033 and some other stuff. Right. So let's go in here and define our colors. 031 one of them should be like a color stop thing as well. Red, yellow, reset. There we go. So reset, that is what I call color stop. And then we just need to do variations of this string right here. Right, there and there. Okay, so green. What is green? Green is 32 at the end. And yellow, 33. And finally, what's red? Red, there, 31. All right, let's see how it looks. So, oh, that's a weird word. Let's try something. Let's see. Paste. Okay, so the P and the A is correct, and the E at the end is also correct, and same here. So the red ones are wrong. I want to try something. If we switch those two characters, then we probably won't get a proper word though, but let's do it anyway. Oh, all right. I want to see if the yellow works as well. So let's do something with B in it, but not this word, and not at that position. Let's do abort again. Ah, there we go. So we have 2 yellow and 3 yellow into red, which means that the yellow ones are in the word but at a different position. Okay, seems like this is working the way we intended to. Let's just remove our little cheat. And at the beginning, let's show a little message. And let's compile our final product. Of course, we introduced an error at the last second. And here it is. Our game is complete. Welcome to Wordle. Please enter a proper 5-letter English word. Good luck. So let's do abroad. No, that was 6 letters. Also 6 letters. Boomer. Okay, that was not in the list. And it's a 6 letters, okay. It's very difficult to find words on the spot like this. Colin? No. Okay, so names are not in the list. They usually aren't in these kind of games. Motel. Okay, the M is right, nothing else. Manga. Nope. Moped. Mumps. Okay, but it works. And how big did it become? Let's see. Oh, 323 lines. It grew bigger than I anticipated, and the structure is not so good as I anticipated either. But it works as intended, and it's safe and secure. Looks kind of nice. I hope you liked this video, and if you want to see more similar videos like this, please subscribe to this channel. Thank you for watching, and thanks for today. Sup guys, welcome back everyone. Today I'm gonna tackle another of these challenges, and today I'm gonna do the one which is called GetNextLine. The task is we should read from a buffer, like from a file or from a network socket or similar, and we're gonna read until we get a new line. Let's make it simple. We read from standard input and we echo it out to standard output, one line at a time. It doesn't have to be more complicated than that, and I want to utilize the heap for this. Alright, so let's begin. And once again, I haven't rehearsed this, so maybe I'll fail. We will see. I am going to include stdio, at least for now, because I want this during development. And this is the gnl.c. get next line like this, and since I'm utilizing the heap, we are gonna need the stdlib library. I think that's the, let's see, man3malloc stdlib.h. That's right. Okay, so we're gonna have a main function as usual, and we don't need any arguments for this one. And then I'm gonna have a function called GNL for GetNextLine, and we don't need any arguments here either, because we're always going to read from the standard input. So, well, let's see. Let's start with the usage. So if we go into the main function like this, and let's create 2 pointers, P1 and P2. So I'm going to read 2 lines, one at a time. And I will just simply do P1 equals GNL, which will read the first line. P2 will equal GNL again, like this. And then I'm simply gonna print them out to the screen. So I will put them in single quotes as well, so we see that we don't include stuff and characters that we shouldn't. And I will put a new line here because I am not going to include the new line in this string. So one of these, and I'm gonna paste in like this. And then we will do P1 and P2. Simple enough, and I don't need to jump all the way like this. This looks a little bit better, I think. And then we will simply return 0. But before we do that, I also want to free these 2 pointers. Like this. Okay, so I'm not sure if I need any additional functions. I think we will see. So char GNL like this, and I put some enter here. Okay, so what do we need? We need a pointer P. This will hold the buffer, and perhaps we should define a maximum buff size as well. Let's say 2048 bytes. And in addition to this this heap segment that we're going to return, I think we will use the let me think. No, let's do it like this. Okay, so let's allocate the whole thing, because we don't know beforehand how much it should be. So we allocate everything, and then I want to zero it out. So I will need another pointer. Okay, so I'm thinking about something like this. I need to log in again. Just 1 second. Okay, so let's read 1 byte at a time into this buffer. And I'm gonna create one additional pointer. Let's call it S for start. So this will have the same value as P from the beginning, pointing to the first byte of the memory segment. But we're gonna mutate P, so that's why I wanted to save it in S. And now we will just do a loop where we read with a read system call, 1 byte at a time. And if we encounter a new line character, what shall we do then? Well, we should do something like this. If we get a 0 byte, then we end and return. And if we get an error, then we also end and return, unless it's the first byte. So if we don't have any other result, then we will error out. Otherwise, if we get an error, we will just return what we have. But then we come to these new lines. We do want to return when we get a new line, same as above. If we have 0 bytes read, then we will also error out some way. But what if we get a Windows-style new line like this? Well, we should tackle that the same way as a regular new line, but how do we read this? Because if we get this R, we can't really read another byte just to check if it's an N. So what do we do with that byte then? So I think the best way is just to entirely skip those, so we don't use them at all. We just delete them. And I think these are all the different cases, because otherwise, if we get a regular character, we add to buffer and continue. So quite simple actually. Okay, let's see. We have a P which will be pointed to the current byte, and we have the S which is the entire buffer. So let's do something like a while loop. So while, let's just do while 1. So an endless loop for now, and then we will enter some conditions later on. Okay, so what we need to do is similar to what we did last time when I did the Printf implementation. We will have a loop. So step 1 is we read a byte from a buffer, and we need to take care of the return value. So let's just do an int r for return value, and r will be equal to read, and we are going to read from standard input, yes, and we're going to read into the P, and maximum 1 byte, like so. Okay, so now we have a value. Now we can switch for that after we have checked if we did get an error. So if r is less than 1, then either the buffer is read in its entirety, so the file is closed basically, and it can also be an error of some kind, but that doesn't really matter because we're gonna handle it the same. We also need a counter, right? I will make this an unsigned int n, and let's set n to 0, like so. Okay, so what do we need to check? We have a couple of different checks. The first is if r is less than 1, which means we are going to check how big n is. So if this errors out, and if n is less than 1, in that case we will just return 0. But if the read operation fails, but we have something in our buffer, then we will just return our buffer. Simple enough. We need to have those brackets, I think. So we don't get any problems with this else statement here. Okay, so if we successfully read 1 byte from the buffer, then we can do another check. So else if n is more than buff size -1. So if buff size is 100, we check that n is not bigger than buff size. We should probably do buff size -2 just to be sure. So if n is greater than buff size -2, then we are possibly overflowing the buff. Okay guys, let's continue on with our code. So the last thing we did was we began checking that the character we read fits inside of our maximum buffer size. So in case this n counter exceeds the buff size -2, and I do -2 so we have a little space there, what shall we do then? We can't really read any more characters, right? So we will simply return s, but we also need to add the 0 byte at the end. Or let's not, by the way. Let's just return the buffer like so, and s is the start of the buffer. And instead let's zero out the entire buffer from the beginning. So let's just do 0 and send the reference of s, and then we will create this function real quick. So we will have a function called 0, which will take in an argument of type string pointer. And return another, or return the same rather, string pointer. So let's just do it really easy. So char p, and we will just we will create an int counter, and we will just do a simple for loop. So we will set the counter to 0, and we will loop as long as n is less than the total buff size. And what shall we do at each iteration? We shall do star and p plus n. Let's do like this. So p plus n plus plus equals 0. And then we don't even need a body for this one. And at the end we simply return p back to the user. And let's make this pointer a constant, because we don't really need to change it. So something like this. So now we can be sure that the buffer is zeroed out at the start, which means we can safely return s as long as we stop before we fill up the entirety of the buffer. Okay, great. So now we have a check that we don't overflow things, and we have a check if the read operation fails. So now we can code the happy path. And as I mentioned before, we will simply do a switch statement. So let's see. We will switch p. And what shall we check for? Well, what about 0 bytes? Shall we break at the 0 bytes? Yes, I think we shall. So if case is 0, we'll just return s. Easy. And this break really doesn't make sense, but I like ending all the cases with a break. And what else? If we encounter an enter character, a Windows new line, then we will just continue, or we will break. And if we see a regular new line, we will return let's do it like this instead. So case 0 and case new line. Then we will return the string, and if we get a regular character, what shall we do then? We have already... Oh, wait a minute. We can't just break at this R because we have already read the character to our buffer. So what we need to do in this case is we need to reset this character in the buffer to 0. And we will not increase the p, but in this case we will increase the p. Okay, 1, 2, 3, 1, 1, 2. Okay, and we can end this if statement. If blah blah blah, else do. Okay. Alright. I have probably forgotten something, but let's test this code and see what happens. So this will be ending the while loop. And this should not be reached. Don't we all love messages like that, by the way, in the code? Because almost at the kind of Murphy's Law, you always happen to end up at this code. Anyway, so what shall we do if we reach this part? Well, let's just let's remove this stupid line and let's just return S in this case. Perhaps we should do a check of this n variable, because we are counting. We need to increase that counter as well. So let's do that here. And instead of plainly return S, we can do a ternary. So if n is less than 1, so if we haven't read any characters, then we will return, let's do it like this, then we will return, do we have any error code? We did make it a char, and in this case we return 0, so let's return 0 if we fail. So 0, otherwise we return S like this. And save. Okay, so let's try this out. We have already written this temporary testing of a main function. So we read two strings and we print them out. So let's see if we get any errors. We probably will. Yes. Assignment of read-only location. It's probably because of that const. Let's remove that. Because it shouldn't be a read-only location. Let's remove this -1 stuff. Okay, let's try it again. Okay, a whole lot less errors. So passing argument 1 of 0 from incompatible pointer type. Okay. So instead of sending the reference, let's just send S. And now we only have one implicit declaration. So man to read uni std. Right, we don't have that, so include uni std dot h. Okay, it compiled. Warning, overriding recipe for target. Ignoring old recipe. Maybe that has something to do with, let's do make clean. Because I have my printf code in the same make file. Let's just do make GetNextLine. Okay. What happens if we do make clean and we compile this manually? So gnl.c-o.gnl. And let's add wall as well. Okay, so no problem. Overriding recipe for target printf. Ignoring old recipe for target. What is that? I have never seen that before. Printf.o. Aha, I forgot to change this when I copy pasted. This should be GNL. Make clean, clear, make. Okay, that's better. Let's try this GNL. And we need to create something which puts a couple of lines of text to the standard input. So let's just create a file. Let's that should do it. So test.txt, this is line 1, and this is 2, and let's do 3 as well, like so. And then we run GNL, and we take the input from that file test.txt. That's what this character means. This is line 1 and this is line 2. It works almost perfectly, but as you can see, with the help of those single quotes that I talked about before, we see that we are printing out the new line, and we don't want to do that. So let's go back to this, and in case of new line, we just return S, but we should set P to 0 first, because we don't want that new line in our variable. Okay. And then we can try it again using the same command. Okay. Still doesn't work. Why is that? Did it recompile? So we read it to P. What happens then? We check if 0 or if it's a new line, and then we set P to 0, and then we return S. When do we increase? We increase down here. So we should be able to overwrite that new line, I think. But we don't. Case we are switching for P. Case N. And we are setting P to 0. Maybe we should do some kind of check. So if P not equal to S, so we should do this only if this isn't the first character. In that case, we're going to check if P minus 1 is equal to a new line. And in that case, we set P minus 1 to 0. And we set P to 0, and we return S. But this shouldn't really happen, right? Well, let's try this, at least as a test. It didn't really remove everything when I did the make command. Make clean, remove Printf and GNL. Like so. And we do the make. Okay, now we get an error. Okay, at least we get an error. And we will remove this code because it's not really something that we need to do. The compiler confused me a little bit. So this ought to be enough. Okay, no errors. We get a fresh GNL file. And then we will just run our command. And now it works perfectly fine. Very nice. Before we end, I will just test sending it a lot of different characters and see what happens. So for E in dollar, let's send 10,000 occurrences of an A to Printf. Okay, it works. Then we will take this entire command and we will pipe it into our GNL. And it doesn't crash. It takes the first 1,000 or so and print them to the screen. So what have we learned today? We have learned how to solve the GetNextLine challenge by using the heap and by using the read system call, which basically lets us read one character at a time in this case. And we check if it's a new line or if it's an error or if it ends. And we return a pointer to that heap area each time. So every time we issue the GNL command, we get one line returned. So that's all for today. If you are interested in this channel and want to see more, please check out the small red button at the bottom right of your screen. It's pretty small, but if you click on that one, you can easily subscribe to this channel. And if you like this video, you can also click the like button, of course. Thanks for watching and thanks for today. Sup guys, today we're gonna do some challenges. The challenge I wanna tackle today is the Printf challenge. At least I wanna start with the Printf challenge. And Printf, maybe you don't think about it, but Printf is a very, what should I say, complicated function actually. There are a lot of different parameters and switches and different percent, etc., etc. So it would take maybe a whole season of episodes to create the entire thing. That's why I'm gonna limit it a little bit. I'm gonna limit it to 3 different variable types. So I'm gonna do %s for string, %c for char, and %d for int. And I'm not gonna use any of these switches like number of zeros or stuff like that. Only these 3. But in order to make it a little more difficult, because this has been done a lot of different times before, so I want to up the ante a little bit, and I'm gonna set some limits. So I'm gonna code it without any libraries, not even the standard C library. The only thing that will be allowed are the system calls. So like read and write and stuff like that. Because if that's not allowed, I wouldn't have to create the calls myself with assembly. And we've done that already. And I want to focus on the C today. So system calls and their wrappers are okay, but nothing else is. And if I get stuck, because I haven't rehearsed this, if I get stuck, no Google is allowed or anything of the sort. The only thing which is allowed when it comes to documentation is the manual pages. So the man Linux command. That is always okay. And my own libraries are also okay. I'm not gonna use a lot of those, but perhaps for one part of the solution. Okay, let's begin and see what we can achieve. So I will code inside the terminal today. And the only thing I have prepared is an empty printf file. As you can see, it's empty. A symlink, which is called A, and that's just pointing to that .c file for convenience. And then I created a simple make file, which will compile everything. So let's begin. And I'm going to begin by creating a couple of utility functions, because if I'm not allowed to use almost any libraries, I can't even include the std IO. UniSTD is needed though for the system calls. Well, I need to define the following utility functions. strlen, because I need to be able to count the number of characters in a string. I will also need something like putS, which works similar to Printf. It puts one single string to the screen, and no format strings and stuff like that, just one regular argument. And I need that for debugging, basically. And I will also create something like, I think I'm gonna name it putChar, which will print a single character, one char. And finally I will need something like char dupe, I think I'm gonna call it. It's a function which will take one argument. Let's begin with that one so I can show you instead. So char dupe will return a string, and it's gonna take an input, which is a regular char. So it takes a char and converts it into a string. So, and this is quite simple to do. I will just create a static buffer of 2 bytes, and I will also create a pointer. Not really necessary, but I like working with pointers. I will point this towards the buffer, and then I want to change the first character to the C, and then I want to increase it so it goes to the next position, and then I want to put the 0 byte there, go back, and then I will just return the buffer. So if I send a J, it will create a buffer of 2 bytes with a J and a 0 byte and return it. Okay, so one function is done. This was the easiest one. Let's test it. We need to create the putS so we can start testing things. I will let this be a void, I think. Let's start there anyway. See if it makes sense to return anything. So putS, and we will take a pointer as an argument. str, and what do we need for this one? It's not a lot, actually. Let's see. We need to write it towards that, and we need the string length. That's right. So let's pause this one, and we will create the string length. So a string length is an unsigned integer, strlen, and we will send a string to it. I want to create some space here. I get annoyed when I have a lot of text below the cursor when I code. Okay, so strlen, what do we need? We need an int counter, so int n, and we need a char pointer, and then we can just do a for loop where we set the pointer. Let's point it to the str, and at the same time we set the n to 0, and we're gonna loop as long as the thing that this pointer is pointing towards is not 0. So we'll just do a star p, and each run we will just increase the pointer, and we will increase n, and that's it. We don't even need a body for this one. And then we return n. I think this should work. Okay, so what do we need here? We need to know the length. So unsigned int n, we set n to strlen str, if n is less than 1, so if an error occurred, or if it's an empty string, then we will just return -1. No, this is a void. Maybe it makes sense to... never mind. Let's just return void. In other case, we will write towards our standard output, and I have a memory rule which you might find useful, and that is 0 is the standard input, 1 is standard output, and 2 is standard error. So first you take the one that is a singleton, because we have 1 in and we have 2 out. And then you take the one that are mostly used, so standard output is used all the time, and then just standard error, which means that we will use 1 in this case, and we'll just send str and n. And let's, by the way, make this a regular int. Then we can do return -1 on this one, and we can return the value that write gives us. So if write errors out, our function will error out. Okay, so let's create a main real quick, where we just test our putS function. So let's do something like hello world, like this. and return 0. And we make this one. Oh, that was a lot of errors. A typo on line 16. Conser. That should be a T right there. By the way, const, I don't think I have explained that. Some people who code C would have omitted const in this case, so would just have char, str. And then they might, instead of using a pointer in addition to the other variables, they would have used this the same. So increase str every step of the loop, etc. But I don't like coding that way, because I think input should be input and output should be output. That makes for less errors. So I make this const, which makes it impossible to alter this argument. Then we try again, and now we do only have one. For p equals str, warning assignment discards const. Okay. When you use const somewhere, you need to use it basically everywhere. At least if you're using, let's see, where were we? It's here, right? So char p const char. Okay. Well, let's make this const as well. And then you might think, well, we are setting this afterwards, and we are even changing this. But it works a little bit differently when they are regular variables. I think the only thing we're not allowed to do is reassign it totally to another variable. Well, we do that here, but you can only do it once. So basically like, like TypeScript. I think. I will double check this and get back to you about it. Okay, it compiled. Hello world. We have created our own strlen, our own puts, and it works almost from the start. Great. And we can't really test. Yes, we can, by the way. Let's test the first thing as well, the char dupe. So we can just do, let's do it like this. We create a pointer, and then we just do p equals char dupe, and we'll send an x, and then we just put s p. We need to start the program like this: printf and echo. There we go, x. So that function works perfectly well as well. I'm going to give you a tips, by the way. When you are working with a specific project in a specific directory, in a Linux or Unix environment like I am here, like I am in this challenges folder, it gets quite annoying if you're deeply inside a folder structure, and this prompt is taking up most of your screen, like mine is now. One thing you can do, which is a temporary thing and it doesn't save that settings, you can do export home equals $pwd. What this means is it changes your home directory temporarily for this session only, and it sets the current working directory, which means my prompt is now this big and I'm still in the same directory. Alright, so what else do we need? I don't think we need a whole lot more. Right, we need one more function, or what we should call it, and that is the put char. The one function like structure which will put only one character to the screen. And I say function like structure because we don't need to create the function for that. It's basically a one-liner, and that's why I needed that char dupe thingy, because I'm going to create a function macro for put char. So, and if you don't know what a function macro is and how it works, please check out my new video from the day before yesterday about function macros in C. So let's define put char with one argument. And what are we going to do? Well, the only thing we're going to do is we're going to call the right function, because we're only going to output one single character, which means if we go to the end here and we check out how our put s function looks, well, we have this check and we call this string length, but since it's only one character we're going to put out, we don't need the string length call. And if we look at the arguments here, this won't change, this is always a 1, and this is just a pointer towards what we're going to print. So this is basically the only thing we're gonna call. So let's define the macro as calling right with a 1 as a file descriptor, and then we make a call to char dupe with the character that we want to print, and we're going to print one single character like this. Quite elegant, huh? No extra overhead from the functions. Okay, so now we have our building blocks. Now we're gonna take on the actual function printf. And if we begin by the signature, so the signature for our printf will be int printf, and we're going to take in an const char fmt. This is the format string, and then ... because this is a variable length argument function. And that is what I need my own library. If you watched my community post today, I showed you a piece of code and I asked you all if you could figure out what it does. And that is exactly what we're going to use now. So let's include, I call it x86 args.h, and it's only one single macro. If we open that .h file, x86 args, this is the code that I showed. The only other thing is this if def, so it checks that we don't include this header file twice. So what does this one do? Let me show you by using the code. Sometimes that is easier than explaining. So I'm gonna create an unsigned int pointer. Let's call it p, and then I'm gonna call the macro, which is args, and I'm gonna send this p like this. And let's just try to print this p, but we need to do a typecast. So unsigned char star, and then another star and the p like this, and return. No, let's do like this, and then we increase p plus equals 4. We move it 4 steps, and then we print it again. And in our main, let's clean this out. We will just call printf with something like %s. %s like this, and then something like arg2 new line. Okay. Print, how do I spell printf? And this uses put. I think I did it right. Make return. That's not the correct spelling, right? I have a bad keyboard. We're still no value. We didn't make it a void function after all. We made it an int, I think. Yes, we did. So return 0. Okay, compiled without errors, and if we run it, boom! But we do only see one. arg1. Right. I remembered wrong, because we can, as you can see, we can already access the FMT, so we don't need that. This is only for the arguments. So basically, this is my own implementation of what is called VA arg, which is a bunch of C macros basically, or perhaps some of them are functions as well, I'm not sure. But you use these functions to handle those variable length arguments. I have actually never used any of these, but I wanted to try to write my own implementation of it. And mine is a little bit easier. They are a little bit more complex with more arguments to their functions, etc. The only thing I do is I create an int pointer and I call the args with that int pointer as an argument, and then you just reference that when you want access to the first argument. And if there are more arguments, then you just increase the p variable by 4 every time you want to point to the next argument. And in that way you can have basically an infinite number of arguments to a function. Okay, that's all for right now. I hope you want to subscribe. Okay guys, welcome back everyone. Now that we have our utility functions done, most of them anyway, we might need a couple of more. We will start coding on the actual printf function. So I'm gonna start to make it work for regular strings and string arguments, as well as char arguments. And then we're gonna tackle the numbers bit. Okay, so I'm gonna read one character at a time, and if we see a regular character, then we will just print it directly to the screen. If we see a % sign, then we will enter another state, and we will wait for the next character and handle that one differently, and then go back to the usual state. So let's begin by defining the actual state. So let's create a definition which we will call, let's call it wait for a char, basically. So I'll set that to 1, and then I will define a wait for let's call it format string, and I will set that to 2, and I usually do a comment like this just to show the bits, because this is a bitwise flags definition. We will probably only need to have one flag at a time, but it's always a good idea to define it like 1, 2, 4 8, 16, etc. in case we would need to combine the flags, which we probably don't. In addition to this, I will create a type definition for a regular unsigned 8-bit char, which I'm going to call state. So we'll keep our state in a regular char. Okay, so let's begin then. We will define our printf. We have started a little bit here. So I have created a pointer which will be pointing towards the variable length arguments, and a regular parameter for the format string. I have initialized my own library for handling variable length parameters, and we have tested it out like this. So let's remove this, and at this point this pointer is pointing towards the first argument. Okay, so let's see. What do we need? We need a couple of variables. I'm gonna create a unsigned char, which is the one we are reading. And what else? We need a state. I will just call that S. And let's create a regular while loop. We also need a pointer towards the format string. Let's call that, I will just do const char f, like this. Okay, so while we still have a value for this f variable, we will, let's see, first we need to check what state we're in, and we need to initialize those things. What happened here? Okay, so first we initialize this, then we will set our state to wait for character. And we will point our f towards the format string, like this. Okay, so we will loop as long as we still have f, and then we will do an if statement. So if if s and wait for char, and this single ampersand is a logical bitwise AND operator. So I could just as easily do this in this case, but since we are using flags, I like using this. Okay, so if we're waiting for characters, then we will switch F. And if we are waiting for a format string thingy, then we will have a different switch. But that too will be for the f variable. Something like this. This should be a pretty good structure, and we want to increase this f pointer one time per loop, so to speak. Okay, so if we start with this switch, what cases do we need? Well, we need a case for the percent. So if we find a percent sign, then we want to, in the next round, we want to look for like an S or a D or something of the sort, which means we will transcend to another state. So I will just set S to wait for format string and break to the next iteration of the loop. I will also have a default case. So this is when we have a regular character. And if we do, I will just put that char on the screen. So like this. It doesn't seem that we will need this C variable, so I'll remove that one. Clean up the typos. So if we get a percent, we change states and continue. If we don't get a percent S, we put that char to the screen. And if we are waiting for a format string, and we get a percent sign, so that's if we have a format string that looks like this, then we want to print that percent sign to the screen. So we'll just do put char and bf, and we need to go back to the regular state because we're not waiting for the format string character anymore. So we'll set the state to wait for char and we'll break. So what do we do if we don't get what we think we should get? Like if we have a percent sign and something like percent x which isn't supported, the only thing we should do in that case is change back the state. So I'll set s to wait for char and break, so we don't print anything. Okay, so we should have enough right now, unless I have forgotten anything, in order to make this work for regular strings without any arguments, that is. So let's just return 0 and end it. We can remove this, and we can remove a lot of these. Let's see what it says. Okay, it's compiled without any errors or any warnings. So let's try it out with just a hello world thingy. Would you look at that? Beautiful. But what happened to the new line at the end? It didn't quite catch that, did it? Perhaps we need to do that manually then. So let's just create another case for when we are waiting for char. So case, and I think it's 10. Let's do something like case 10 and case 13, because sometimes we use both of those. So if we get any of those, then I want to check if percent f plus 1, so the next character, if that is equal to 10, or if the next character is equal to 13. So now I'm handling if we get like one of those. Then we don't want to handle both of them like a new line, because in that case we will not be able to, well, we will get a double new line, which is not what we want. So we will check if the next one is also one of these two, and if that is true, we will simply increase f once more, so we just make a jump over it. That should work, right? And we will put char 10 and break. I think this will work. Let's try it out. No, it did not. Why is that? What if we were to do both N and R? Should be the other way around, I think. Like this, a Windows-style new line. Okay. Printf hello world rn. Let's compile this one and we run it, and then we try it out with strace. strace is a great tool for analyzing system calls. So we see all their arguments and the result of the system call. And in cases like this, it's quite nice to have something like that. Okay, so let's see what happens. We should see a, let's just do this, and we grep for write one hello world. It sends the entire string. Now that's pretty weird. But we are telling it to, maybe it's not calling the right function. What if we were to add a 2 after each function names, so it's not colliding with the regular functions with the same names? So this will be strlen2 and put s2 and printf2. This should also be strlen2 and wait for char. Put char 2 and printf2. What happens now? Did I miss anyone? Implicit declaration line 69. Put char 2. Okay, it's compiled. Hello world. No, hello world. That's interesting. What if we were to do an S trace then? And if you wonder what this means, those messages that we see here on the screen, they are sent to the standard error buffer, and the regular program output is sent to the standard output. What this command does, it smashes them both together. So 2 is standard error and 1 is standard output. And this redirects standard error to standard output, which makes it possible to grep for stuff, even in this type of thing. Okay, let's see. Write one, write one, write one, write one. Okay. Looks nice, but what about the first? Hello. What happened to the age? So f equals fmt while f plus plus. Perhaps we need to set this in parentheses so it not increments it directly from the start. And now I don't think we need this case anymore. Let's see what happens if we comment this out. Okay, the new line still works, but we have this problem still with the first character. So let's retrace our steps. We set f to fmt while blah blah blah. This should not alter the pointer until the next iteration, I think. Perhaps it does it directly, because we don't have any other thing that can disturb it, right? So case percent is not happening. The only thing is default, which does put char on the f. And then we have a little else if statement, which shouldn't happen. Okay, that's probably it. I thought the while didn't increase this pointer until the next iteration, but perhaps we can do something like this instead. Do and at the end we will do while percent f plus plus. Maybe we even need to do plus plus f in this case. Let's see what happens. Okay, now it works. Great. So, if you wonder what I did, there are two ways of creating a while loop. It's the regular way, like this, which will loop all the code in here, and it will check this condition at the very beginning. So if this is not true, nothing will be evaluated in this while loop. But sometimes you don't want this conditional check to happen on the first iteration. And then you can just put do here instead. And at the end, you put the while and the condition. So this means that these lines will always happen at least once. And then at the end we check, should we continue the loop? And this was a good example of when we needed to do that. Okay, so let's see what happens if we do %. If it works correctly, we should get, let's put some text afterwards as well. We should get 1% sign on the screen and then the ABC afterwards. Yes, great. Okay, so that works. Now we're gonna do a little bit more advanced stuff. We're gonna take care of the arguments. So we have this p pointer, which is currently pointing to the first argument, which means we should, let's see, in the default case, when we have a failed % with a bad sign, we shouldn't print anything to the screen. Sorry, this is wrong. Default here. We shouldn't print anything to the screen. We should transcend into the wait for char state, but we should also increase the pointer, because if we are calling printf, and let's say hi %s, and then something %x, which is not supported, and then something else %s, which is supported. In this case, we will have 3 additional arguments. So let's say we have a string variable called name, and then we have some foo, and we have some bar. If we're not incrementing when we fail to print foo, this will be unsynced, because this % refers to the third, which is this, and everything will be out of order. So this should fix that problem. What else? Well, let's see, default. We would put in, let's begin with string. What shall we do if we encounter a %s? We already have the pointer p pointing towards the correct argument, so we should basically just send that to %s, and we need to do a typecast, so unsigned char star and then another star, because we are pointing towards a memory space which contains an address to the argument. So we need to go into that address and grab the value. And that's why we need the double asterisks. So something like this. And then we need the actual pointer as well. And then we will just increase this one. Right, we need to increase it by 4, not this like this. So p plus equals 4, because every memory address in my system takes up 4 bytes. Okay. We also need to change state. We need to go back to the wait for char state. And finally we'll break. Okay, let's see if this works. I will just create the pointer like this and point it to something in the data segment. Let's put in my name. And then I will do like this. And I will send P. Okay, let's see if this... Oh, what happened here? Put S, we don't have put S. We called it put S2, right? So put S2. And another typo at line 92. You probably caught that error. And it compiles. And it kinda works, no? Hello, hello. So what are we seeing here? It prints out hello, and then it prints out the format string. Okay, so we are probably off by 4 bytes. Where is it? Here. Let's do an increase of this plus equals 4 from the beginning. Right. Yes, let's do it like this. And we make and we run it. Okay. That's not correct either. I just came to think about something. It is an int pointer, so perhaps it jumps 16 steps if I increase it by 4. Is that perhaps the case? What if we were to do just this instead? And wait for char, wait for format, and we come here, and we will just increase it like this. let's see, we break out here and we come down here. And we will increase in this case as well. Okay, there we go. So when you increase an int pointer, it jumps 4 bytes because an int is 4 bytes. And when we do what I did, we increase it by 4, then we jump 16 bytes, and we end up totally wrong. Let's see what happens if we create our first example again, when we have a variable pointing towards a string in the data segment. And we will just send the pointer like this. Still works. Beautiful. Okay, so now that we can send string arguments to the printf function, the next step should be rather straightforward. We will do the same with chars. So let's go into our switch statement for the wait for format string section. And let's create a case for the C character. So what shall we do if we get a C character? In this case, we should call our putChar to a function, and we shall send the next function or parameter in line. So this time we should typecast this as an unsigned unsigned char without the star, but still this star, I think. Let's try that out first at least. And then we increase our pointer. We set our state to wait for char, and we break. So let's see if we can send the contents of a char. So let's remove this code, and we will put in a char named C. I will set this to the letter X, and I will just simply change this S to a %C instead, and this I will change to C2. Okay, let's see what happens. It compiles, and it works. Beautiful. So let's see what happens if we use both of these. So we have 2 arguments. So let's put back our P pointer, and let's point towards my name again. And let's just put something like this. And then we will put our P right here. So something like this. Let's see what happens. And it works. This is fantastic. Let's see what happens if we change place for these two. I want to see that it works properly with the increase, so it's not a problem that the char is 1 byte and the others are 4. So let's change this to a C, and this to a S, and this to a C, and this to a P. So it should say hello X and Jonas ABC if it works. Yes, works perfectly fine. Great. Now we do only have one thing left, and that is to print out a number. And that sounds simple enough, right? Well, maybe not. Because in order to print out a number, we must convert that number to a string. And this would be very easy if we were allowed to use the standard C library, because there are a lot of functions like that. But we're not allowed to use that. So we need to code our own function which transforms an int into a string of number characters. So there, in the standard C library, there is a function which works in the other direction, which is called A2I. So this takes in a string and gives out a number. So let's name our own function I2A instead, and a 2 at the end. Okay? So int I2A2 let's see, it takes in an int n, and it returns a string. So something like this. So how do we do this? Let's say we have the number 1, 2, 3. If we were to divide this number by 10, what do we get? If we were allowed to use floats, we will get 12.3, right? But we don't have any floats. So this will result in the number 12, and we will get a rest number, a modulus of 3. So if we take this 12 and divide it by 10, okay, this is a bad representation. Let's do something like 12, and then I will put a 3 in parentheses. And if we divide the 12 by 10, we will get 1, and then a carry of 2, right? Because the 2 is what's left after we have taken 1 times 1 times 10. Okay, and then we have the single digit left, and then we just use that. And if we were to do this, I haven't tried this before, but I have thought about it, and it seems it should work, right? Because here is the 1 and the 2 and the 3. So we would get all the numbers in reverse order this way. Okay? So let's start out there. And we have the N. I think I'll do this by unsigned to begin with. So unsigned int, and let's call this x, and then we will have a unsigned int array. So let's call this x's. And for the sake of this, now we can think like this. There is a limit how big an int can be, right? So it's basically 4.3 billion. And how many are this? We have 3, 6, 9, 10. So we will not need more than 10 numbers. So let's set x's to 10. That's the size. And let's see what we can achieve. I will do this manually first. So I will just set the x to, let's use 1, 2, 3. And I think we might need a y as well. So x is 1, 2, 3. Then I will set the y to x divided by 10. This should generate the 12. So y has the 12. Alright. And we need to store the modulus, but we can put it in our buffer. So let's do x's, and we will worry about the reverse stuff later on. By the way, we don't need this as big as an int, because it's only one number, one digit per variable. So a char ought to do it. So I'll set x is 0 equals, and now we do the same thing. So x modulus 10. So the percent sign is the modulus, which also creates a division, but it collects the carry, the rest bits, the rest digits. Okay, so x's contains that. Then we go to the next step, and x, let's set x to y, because y contains the 12. And then we do the same thing again. Y equals x divided by 10. And this time it's 12 divided by 10. So we should get a 1 in the y. and in the x's we should get the 2, right? If we do x modulus 10. And then we will just do something like if y is less than 10, we will simply do x is 2 equals what we have left, which is y. Something like this. I'm not sure how well this will be working, but we'll see. And I will cheat a little bit and do the printf here. That's only because I need to know if this works or not. But as I mentioned before, during the development I am allowed to use libraries, but the final product can't use any external libraries. Okay, so now we print. What do we print? We should print something of the like. It will be 3% these here, right? And a new line. And then x is 2, x is 1, x is 0. Okay. And I will temporarily include the stdio. And then inside of main we will just call this function, and we called it a to I to a2, and we supply number 1, 2, 3 like this. Oh, I didn't remove that, right? No. It compiles. And we get 1, 2, 3. It seems like this is working just fine. Great. So now let's see if we can make this into a loop of some kind, because currently we did do every iteration manually. So how do we figure out where to put the respective numbers? Loop. Let's start there with the loop, I think, because we have this if statement here. If y is less than 10, then we should do something. So we can loop until y is less than 10. Let's do that. So while y is more than 9, Then we should have this loop. And the first step is always to put x to something. And y should, from the beginning, be set to n, which is the number that we are supplying as a parameter. Okay, so far so good. And then we will do the actual calculations. So y equals x divided by 10. And how do we know in what position of x's to put it? Let's just put it at the first position for now, and then we will worry about the reverse order later on. Which means that we need a pointer as well. So unsigned int, no. Yes, it should be an int. Unsigned int p, and we will set p to x's. So y equals x, and then we do x's plus plus equals x modulus 10, something like this. And this will loop until y is less than 10, and then we are down here, and then we should do one additional x's equals y. So x's equals y, like this. Can remove all of this stuff right here. Let's print out these just like we did before to see if it works the way we intended to. Okay, an error, x is plus plus, p equals x's, incompatible pointer type. Oh, not x's, we are using the wrong variable. Right. I think we should use x's instead, by the way. So let's remove this one. And let's create a pointer out of x's instead and remove this pointer. And then we will set x's equals malloc 10. And we shall remember to free that one. So x is equal malloc 10, x's. But now we have changed the x's. Maybe we do need that pointer after all. Let's just do it like this. So x equals malloc, p equals axis, and then we will replace those with p. Something like this. Okay. Oh, that's quite a lot of errors. What did we do wrong? Okay, we don't have malloc. We will include mallocs. Include stdlib.h, make, and now it compiles. Okay, we did get the one to, okay, we freed the wrong variable. Right, yes, we need to free p, not x's. Okay, 1, 2, 3. It works in our easy example, but it won't work for anything just quite yet. It will fill up all of these places. So what do we need to do now? We need to plow through this buffer in reverse order, and we need to interpret the numbers that we do have there, because what we have at each position is like 5 or 2, etc. But 5 or 2, etc. has different meaning for a char, because char is using the ASCII table. So let's present it like this. So if we have, for instance, a %c and then 61, and we get a 6. No, doing it wrong. %c, I think we should do it like this instead. So 41 in hex, that is a big A in the ASCII representation, and it's B, etc. So what we have is 0, 1, 2, and we need to change that to the ASCII representation of the numbers. So can I somehow get it from this printf version? What do we need? We need a %c. And what do we get if we just do a 1? We get the 1. Three. 0. Do we have hexstamp installed here? Yes. Okay, let's do hexstamp instead. So let's printf the number 1, for example, and then we do a hexstamp. Here we can see it's 31. And if we were to do 5, it's 35 in hex. So that means we have a span from 0, which is 30, all the way to 9, which is 39. So basically that means that we want to take a 39 of hex and turn that into a, no, the other way around. We want to take the 9 in hex and turn that into the 39. So we should just be able to add the hex value 30 to any of our numbers, right? Which would mean if we were to do like in 32 here, we should get a 2. Yes, we do. Okay, that makes stuff easier. So now we just have to reverse this and alter the numbers. So let's create macro for the swap. So define swap char of x, and that should be x plus the hex value of 30, like this. Maybe we should add some parentheses too. Okay, so now we have a swap char. Now we need a reverse. Maybe we should have some kind of ending character. Or do we need that? Because axis is pointing towards the last one. So if we start by axis and count down to P, we should be all right. So while axis is not equal, or maybe we should do while axis is less than P. And we need an additional buffer that we can return. Let's make that static char. So static char return, and we'll make 10 of these. Like this. And we need a counter for them as well. X and Y is not needed anymore, so we can take them. Maybe we shouldn't use a while loop then. We will do for and we will set x equal to 0. We will loop as long as x is less than p, and in each iteration we will just increase the x. And what are we going to do? We're going to set the ret of x equal to swap char of x's. I think that should be right. And then just at the end of the loop we will ret x. This has increased. We will set rect plus x equal to 0. Something like that. And we will free that buffer, and we will return rect. Something like that. Okay, so I2A, we need a printf here. Let's do like this. So we will cheat with the printf, and we want to output I2A2 of the number 54321. Let's see what happens. It compiles. Okay, we're on the right track, but it seems like the calculation didn't work out quite right. But let me try something. If we go back here and we do, let's do something like 1 to 1. Five to 2 plus 7. Ah, wait, I have %d here. This returns a string. Let's try it now. So now it should say 1 to 1. Nothing. Who said coding was easy? Okay, let's try another number first. Let's do 5, 4, 3, 2, 1. Nothing. If we were to do an S-trace, we would probably not see much. Three. And an L-trace. L-trace is the same as S-trace, but we see the library functions instead of the system calls. But I doubt that'll help us much because we're not really using any external libraries. But perhaps we see something here. So ltrace. There we go. Okay, so let's check out the ltrace output. That's not much. We allocate the buffer, we free the buffer, we send the printf. So what went wrong? Let's go through the code again. So what do we know? We know that this part works. So we do get the numbers in reverse order into our array. Then what? We do a for loop. X is 0, x is less than p. Perhaps this should be in the other direction, less. I always forget how the memory is, or the memory addresses are growing. X is more than p. Wait a minute. Let's see. X's, p and x's are the same here. Then we increase x's. So x's should be bigger than p. Okay. Hopefully this is it. Segmentation fault. Okay. So let's do the ltrace. Malloc and then crash. And then strace. So this is basically the negative part of doing everything ourselves with not using any libraries. It gets a little bit tougher to troubleshoot. But let's see. Why does this not work? As long as x, do we decrease x's somewhere? No. Okay. Because we definitely should. So each iteration will do x's minus minus. Like this. Okay, let's try it again. 5, 4, 3, 2, 1. Okay, we're getting close. We didn't get the 1, but I think we forgot about that actually. Because we do, so we loop until y is not longer bigger than 9. And then at the end, we put x is equals y. So that should be the 1. But, and x's should still be pointing towards that 1. So when we go into the loop, ret x equals swap char x's should be the 1. Or maybe we don't do the last iteration here. So y-axis is more than p. What if we were to do just another one of those? We'll let rect equals swap char x's. Let's just try this. And there we go. 5, 4, 3, 2, 1. We have successfully created our own I to A function, which should make the last part of our printf quite straightforward, right? So let's go back to the printf and let's go back to the wait for format string state, and we'll create a case for the D character. And what should we do when we encounter a D character? We should put string 2, and what should we send? We should send I to A2 of unsigned char star p, and we have that parentheses and that like this. We should increase p, set the state to wait for char, and we shall break. Something like that. Okay, so let's clean up our code. Let's remove this printf. Let's go to the beginning and remove standard IO. And let's test if this works. Let's create an int to call x. We set it to 501. No, 5010 is good. And then we will do printf. No, not printf, printf2, our function. And we will say something like the magic number is %d, congrats, something like that. And then we will just give x as the argument. And x is a value, it's not a pointer. We need to take that into account, so we should strip one of the stars, right? Sure, like so. Unsigned char. Because we're going to send a number to that function, and we shouldn't even do char, we should do int, right? Let's try this out. Oh, that's quite a lot of errors. Warning, implicit declaration of I to A2, I to A2. What did we call it then? I to A2. Wait a minute, perhaps it's just the order of our functions that messes this up. Could it be so easy? Let's create some function definitions then. So what do we have? We have the char dup2, which takes a const char. Then we have strlen2. Okay, what happens now? Okay, we removed almost every error message. So conflicting types for printf. Const char fmt, const char dot 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 int. Okay, int and void. Forgot to change that. Okay, now it compiled. Let's see if it works. Okay, the number is not the right one, but that's probably because we messed around so much with the typecast. Because let's see where we have the %d. It's right here. It should, I think we should at least have, let's see, unsigned char. I think we should at least have one of these stars. $50.10. Congrats! So we have succeeded in creating our own printf implementation, including an own varg implementation for dealing with the variable length arguments, and a lot of different utility functions, so we didn't even need to use the standard C library. If you like this video, you should subscribe, because I will create some more C videos soon. And as always, I release an episode every week, and I lift up an older episode as well for you to take a look at. So that's all for today. Thanks for watching, and thanks for today.
Okay, welcome to today's lesson. Today we are going to do an assignment together. We will do this dice game assignment. And if you haven't already tried it, I think you should begin by trying it yourself, so you learn a little bit more from it. If you are not able to make it through the assignment, then you could watch this episode and learn how to do it. I think that's a pretty good order of operations. Anyhow, The task is creating a simple dice game where you have $1,000 to begin with, and you bet like $100, and then you throw a dice, and you make a guess what it will land on. And if you're correct, then you will triple your bet, and if you're not correct, then you will lose what you have bet. And then you play around a couple of rounds until you are satisfied with your score, and then you quit the game while on top. If you run out of money, then it is game over. Okay, I will jump right into it. I will create a file called dice1.c and enter a little bit of comments in the top and our main include file. I will also add a couple of more, like unstd, so we get the sleep function, and I will also need the stdlib.h, so I can use getPid and the random numbers. Okay, and I will begin by creating a function, actually, because we can't do much with this code unless we have a random function. So I will do something similar to what we did in the random episode. I will create a function called, let's call it random. I'm not sure if that's taken already, but we'll see. And then I will have a max limit. I will create a variable to make this look well, so you can follow along a little bit easier. And I will call the rand function. I will modulo it to the max and add 1. And then I'll simply return x. So now we have a random function. Let's begin by looking at the assignment. We need to create a variable called balance and assign the value of 1,000. Okay, first we need to create the main function like this. Yeah. Okay. Balance, and it should be an int, so it can hold a number. I will set it to 1,000. And the next step is to ask the user to bet and read that bet into the variable bet. So I'll do these two together. So we need another int, which we'll call bet, and we will print out to the screen, make your bet, and I will flush that in order to make it seen on the screen immediately. Okay, so what do we need? Ask the user to bet, then read it to the valuable bet, and we use scanf, so we can read that from the keyboard. Then we are done with that. Now, as it says here, code a couple of points of the instructions below, then compile the code and try it to program, then continue on with more coding points. And that's a really good point, because if you make all this at once, even if you're a skilled, experienced programmer, you will most definitely have a lot of errors. But if you make like 3 at a time and save and try it out, then it's much easier to troubleshoot. So that's exactly what we'll do. We'll compile this code. Now we got an error. Yeah, look at this. As I mentioned before, or as I suspected before, previous declaration of random. So some of the keywords in C are already taken by other libraries. So let's call this my. One let's call this my random instead. Now it compiled just fine, and we run it, make your bet, 500, and then it exits, because this is all we have done so far. Okay, what's the next? I'll do these two at once. Ask the user for a guess between 1 and 6, and tell the user to guess 0 in order to quit. Read the guess into the variable guess. Alright, so we need another variable, which is an int. I'll make a little space here so we see that it is a different section. It's completely fine to have line breaks in C. Pretty much everywhere, not exactly everywhere, but close up to it. Okay, ask a user for a guess. Then we will have our printf again. Make your guess. 1, 0, and 0 means quit. So 1 to 6 and 0 means quit. That's possible to understand, right? And we don't need to flush it this time, but we will use scanf to read it into the guess variable. And then if the guess is 0, then quit the game. So we'll have an if statement. If guess equals 0, then return 0. We need to exit the game. And as you can see, I didn't have any brackets here. And that's because there's only one line of code connected to this if statement, and then you don't need those brackets. Okay, so let's save again and compile and run. Oops, there we go. Make your bet 500, make your guess 5, and then it's done. Now we should pause the game for 2 seconds, generate a random number. Because we have already prepared the random function, and before I forget, we should add this srand thing in here as well, so we don't get the same numbers all the time. And this should be on top of your code inside your main. You can have your variable declarations before it, but then it should come, and you should only call it once per program run. Okay, pause the game. Then we will do sleep2 and generate a random number, which we will store in a variable called dice. So we need an additional int variable, which we'll call dice. And dice will be equal to my random. That's the function we wrote. And we want the 6 to be the highest possible number. And let's print that one out on the screen so we can see what's happening a little bit. And let's try it out. 500, 5. It pauses for 2 seconds, and then it prints out what the dice landed on. Okay, so what's next? Check if the guess matches the dice. So it's another if statement. If guess, it says it like this. Check if the guess matches the dice. If they don't, subtract the bet from the balance. So in this case, it's easier to check if it's not equal to. If guess is not equal to dice, then we should lose money, right? And we should subtract the bet from the balance. And how do we do that? We do balance equals balance minus the bet. Because if we have 1,000 and we have bet 100 and lose, then it should be 900, right? 1,000 minus 100. We can also use the other method we discussed in an earlier class. Balance minus equals to bet. That's the same. It will reduce this variable by this amount. And I will keep these brackets here because I will add a couple of texts later on. Okay, so if this isn't true, if we actually won, and that will be our else statement, and what will happen if we win? If they do match, multiply the bet by 3 and add that to the balance. Okay, so we will take this in 2 steps. We will begin by multiplying the bet by 3. So bet equals bet times 3. And now we can try if this works, that I talked about last time, and I said it probably works. So this should be the same as bet equals bet times 3. So if we did bet $100, then our bet should be 300 after this. And now we only need to plus that to the balance. So these 2 lines should add those $300 to our balance. Now we should check if the balance is 0 and then quit the game. So if balance equals 0, I will print out game over. And exit the game. And now it's time to see what we have done this far. So make your bet like 100, make your guess 2, and I bet 2. I don't really see what's happening right now because we don't have any texts like saying how much our balance is. So let's add that. Printf balance. We put a $sign and then the amount. %d for an int, the value of balance. And where are we? If the balance is 0, quit the game. We have done that. If the balance is positive, loop the game to be able to play more rounds. Yeah, we should be able to play more than 1 round, which means we would loop almost our entire code. So if balance is 0, then it quits, which means we don't need another else statement here or another if statement. We can just put our code here because it quits if this is true. Okay, and we should loop this code. So let's start with where in the code we should add our loop. How much of this code do we want to loop? Variable declarations, we only do that once. The srand, we should only do once. What about balance equals 1000? If we loop that every time, the balance will be reset and you can't win or lose any money, so not that. Make your bet. Yes, we should be able to make a bet every time. So right between here is where our loop should begin. So we can do a while one loop to loop everything. And I will jump out 1 step everywhere, which will make this code much easier to troubleshoot. It's a little bit tedious to do this, but it will be worth it later on. There we go. And there is where our loop should end. So all of this code will be, all the way here, will be looped all the time until we run out of money or quit the game. And now we should add a couple of texts. Throwing dice, congratulations, you lost, your balance is, etc. This one we have already done. We could better this a little bit. Dice results. And throwing the dice, let's put that before the sleep. Throwing the dice like this, and some congratulations. You won. Congratulations. And if we lost, let's just print. Sorry, you lost. Something like that. And your balance is already done. Throwing the dice, congratulations. Think that should be it. The only thing we have left is add some comments to your code. Okay, that's always good to do, because even if you understand all of this code, and you probably will understand it even a week from now, but if you go back 2 years from now, would you understand every bit of this code? Probably not. So comments is for your own good. This will create a random number between 1 and max. And we could add seeding the number generator, the random number generator, to be more specific. This code is probably quite self-explanatory. Maybe we could add something here. User presses 0 in order to quit. Something like that. Okay, let's save. And we compile and we run. Make your bet. 50 and 2. Throwing the dice, and the dice results 4. Sorry you lost, and the balance is 950. It works just fine when we lose. And we probably need to play a couple of rounds before we encounter a win. If we want to make this a little bit faster when we debug the code, we could disable the sleep directive. Ah, here we go. I bet 60. I had 800. I bet 60. And I guessed the number 6, and the dice landed on the number 6. And I won, congratulations, and now I have 980. And 60 times 3 is 180. Which is correct. Works. Okay, so if I just make any bet and then I choose 0, the game ends. What if I use up all my money? I bet 1,000 on 6. Okay, I won. I bet 4,000 on 2. There we go. It landed on 4. I lost all my $4,000. Sorry. you lost, game over. So our code is complete. So what have we learned today? We have learned to use all of the different parts of this beginner's course. And we have learned something else as well. Let's go into the code one last time. We do this and this and this. I think we have learned each and every different part of this code before. So what we have learned is how you use it all to make a big assignment. Now I hope you will try it one more time for yourself, the assignment that is, and see if you can't create this game on your own. And this concludes the current beginner's course. Perhaps I will add more lectures to the future, and I will start with the advanced course. You are welcome to join me. Thanks for today, and thanks for watching.